Hi, I'm Narendra Kumar. I'm a senior data architect with 12 years of experience in IT. I'm a certified Databricks solution architect champion as well. And in this video, we are going to build an end-to-end streaming data project. We will mainly build it in Databricks Free Edition. And to bring in streaming data, we will set up our own Confluent Kafka account for free. We will send real time data to our topic, then process that data in real time and generate immediate email alerts based on the detected fraud. And apart from this Kafka streaming source, we will also set up a file streaming source of our own. And then we will use a third source as Postgres SQL that will be a static source so that we can understand how can we join streams, how can we join static data with streaming data. So all those scenarios we will cover, and we will also build an dashboard that also will refresh in near real time. And apart from covering all these things hands on, we will also cover the theoretical part also so that our basic is strong. We will understand all the streaming concepts, the Kafka architecture, the stateful and stateless streaming processing, how we can handle late arriving data using watermarks, how to use tumbling and sliding windows, and then do aggregations on the streaming data. So, all these concepts we will clear, and whatever data code and other files that I will be using for this project, those I have uploaded them on GitHub so that you can also do a hands-on on your own and be confident with it. I'll also provide a link to this presentation as well. And to help you further, I have prepared this PDF document with all the project details, including the details that you can directly put it in your resume. You can use this document as a revision document before going to any of the interview. I have created four other projects as well related to batch data processing, AI, and data modeling. I have also created an interview series, and there are many more videos related to data engineering. So feel free to check them out. And if you want to stay tuned for more such videos, you shall hit the subscribe button. And if you are already a subscriber, then let's get started. Let's start by understanding what exactly is streaming and how it is different from batch processing. So streaming, it is the continuous ingestion, processing, and analysis of real-time events, which enables low latency analytics and immediate decision making. What it means is that in streaming, we continuously ingest new data, we process it and analyze it in real time so that we can make any decision with minimum latency in sub-seconds or seconds. And how it is different from batch processing is that in batch processing, we collect data over time. We keep collecting the data maybe for 1 hour or sometimes even for a day. Then we schedule the jobs on daily or hourly basis, which process all the data which is accumulated over that period of time. And then we write it to a storage or we do whatever we want to do. Whereas in streaming, we don't store the data over period of time. We move it as and when it is being generated from the data source till our analytics system. So even a single event which is being generated, we uh, keep pushing it. We don't wait for any more events to be gathered, so that the latency is minimum. So the data, it is coming continuously without any delay, and then we process it in real time as and when it is coming, which provide instant results and insights. So if we visualize it in terms of timeline, so let's say if the data is being generated, here each dot represents a data point. So in batch processing, we collect the data over some a period of time, then we process that batch. Wherein in streaming, we process each and every event as and when it is coming. And the examples of batch processing are like daily sales reports, monthly billing, payroll processing, or historical data analysis. These kind of examples come under batch processing. Wherein stream processing, it comes like a real time fraud detection or live dashboard, or if you want to monitor IoT sensors in real time. If users are clicking on website, we want to monitor that in real time, or stock price monitoring in real time. So all these examples are of stream processing. So batch processing, it is based for uh, huge volume of data where latency is acceptable. Wherein stream processing, it is for low latency and wherever we need any immediate decision. And in our demo, we will be using Databricks, which supports both batch and stream processing. So now, as we understand both types of processing, next let's understand a use case. We will pick up that use case, and then using that use case, we will build it step by step. And along the way, we will understand each and every concept of streaming as well as batch processing. So the background for this FinGuard use case, FinGuard is like a financial guard. So the background for this company is that it processes millions of credit card transactions daily, which comes from ATMs, point of sales terminals, and other online payment gateways. And this bank, it receives continuous fraud intelligence from internal fraud teams also and external security partners also. They get some data in some form like JSON or other files, which tells which cards are marked for fraud and all. And then the problem is that the delayed fraud detection, this can result in significant financial loss and poor customer experience. So the problem they are facing is that whenever they get continuous transactions and fraud related data, they are not able to act immediately and they are not able to detect the frauds immediately in current scenario. So this is the background. Now the core problem is that the fraudulent transactions, those must be identified within seconds. So that is why it has to be some processing in real time. And then fraud indicators, they arrive from multiple sources like live transactions, some watch lists are there, some customer master data is there, which all these come from different sources. So currently there is no way to combine all that data. In the traditional batch processing, this cannot react quickly enough to prevent fraudulent activities. So if we do a batch processing here, hourly or daily basis, it is not sufficient because frauds has to be detected immediately and then decision or the action has to be taken immediately. Then the solution approach is this. So we are going to ingest real time credit card transactions from Kafka. So they get the transactions in Kafka, and that we are going to ingest using managed streaming pipelines. Then we are going to also continuously process fraud watchlist updates that we get as a JSON files. This is also streaming data. We will enrich it with transactions and also with the customer and merchant reference data. And after that, we will apply streaming joins, window based analytics, and we will detect frauds in real time to generate real time alerts and operational dashboards. So, this is the solution we are going to build in this video end to end. So as we understand the overall use case, now let's understand the architecture step by step, how exactly we are going to build this. So we will start by setting up a Confluent Kafka source of our own. We will set up the source, we will send some credit card transactions to it, and then we will receive those transactions on our side. So we will consume those transactions from Kafka using Spark streaming. uh, Using this, we will ingest that streaming data and then we will process that data. For processing, we will use Lakeflow Spark declarative pipelines. Previously, these were also called as Delta Live tables. Now they call this as Lakeflow Spark declarative pipelines. So using this, we will process the real time data, and along with the streaming data from Kafka which come as events, we will also ingest some streaming files. So these will be in JSON form. These will be the watch list data that comes, which tells which of the cards has been marked as the fraud, and there shall be no transactions coming from Kafka for those. So that those streaming files also we will generate on our own continuously. Then we will ingest them in real time using autoloader. And after ingestion, we will process them also using same declarative pipelines. And along with these two streaming sources, we will also ingest the data from Postgres SQL, which will be the customer master data. And then this data we will ingest from a Lakeflow Connect. So this will be a batch ingestion because this customer related information, it is kind of static, it doesn't get updated like in seconds. So this data also we will bring in here. After that, when we process the data using these Lakeflow Spark declarative pipelines, that time we will build the standard bronze, silver, and gold architecture for real time data processing. We will see what we do at each and every stage as per the industry standards. And when we build these layers, we will be building all these in the Delta Lake. We will be building the streaming tables as Delta tables. And along the way, the processing that we will do that will include stream join, that will be joining this Kafka stream with these streaming files. It will also include stream static join, that will be joining this information with the batch data that we are ingesting. And we will also detect the frauds in real time. And once we have processed all that, then on the consumption side, whenever we will detect a fraud in real time, we will send real time alerts as emails. So we will see that immediately how custom emails will be sent. And then we will also build the dashboard which will refresh every minute, and it will provide the updated data, up to date data for each and every minute. And once we have built everything which is running fine end to end, then we will orchestrate it end to end using Lakeflow jobs. And we will run it end to end in real time for an hour or so that we will see the streaming data flowing throughout the system. And for governance, of course, we will use Unity Catalog, which is ready to be used within Databricks. So now, as we understand the overall architecture and what exactly we are going to build, so let's start building this. We will start by building our actual Kafka source. But before we go ahead and build it, first let's understand the key terminologies in Kafka and how does it exactly work, so that when we create it, you are able to relate all the terms and all the items which are there. So this is the standard Kafka architecture, and this architecture it is followed by most of the streaming services as a standard. So on the left side, we always start with producers. So producers are like the data generators wherever the actual data is being generated in real time. It can be a web application, mobile application, any microservice, even from databases, and then there can be many more. So producers they publish the messages, and where do they publish the messages is with to the Kafka cluster. So we set up a Kafka cluster where all the messages coming from the producers are stored, and within the cluster we have something called as brokers. So brokers they are the actual Kafka server that stores the data. So these are like the actual nodes where the streaming data is stored, and it is like managed. And how it is managed is in terms of topics. So topic it is like a logical channel for messages. So if you have worked on any database, so topic you can relate it to kind of a table. So on a database we create a table and then we put some data into it and then read the data from it. Similarly, in terms of streaming data, we have a topic. So we have a topic, and in that topic we send some data to that particular topic and then read the data from that topic. So the name of the topic is very important, and in one cluster there can be multiple topics, like we have multiple tables in databases. So that is why this logical understanding of topic is very important. We can correlate it as a table, but there is no actual table here because these are all messages. But topic is the logical channel where we send and receive the messages. And because these streaming systems they can also be very high, uh, they can also receive very high volume of data. So they also have to support parallel processing, and they have to support massive volume of data which can be there shall be incoming and outgoing of messages in real time. So for that, what they do is to support the parallelism within a topic. They create multiple partitions. So within one topic, we can have multiple partitions which we configure while creating the topic, which that we will see when we do that. So if within one topic we have multiple partitions. So whenever a publish producer is sending message to a topic, it can go to any of the partition. So if there are like multiple producers data coming in, or even if it is coming from one, the data will be distributed across different partitions so that it can be written in parallel and it can be read in parallel. So to consume the data from these topic, there is something called as consumers. So consumers are the entities which consume the data or which read the data from these topics. And the consumer, these can again be any analytic system. It can go to any databases, machine learning, or dashboard. So there it can go for any consumption. But the actual consumer, technical consumer, it can be any programmatic consumer as well, which can read the streaming data and then put the data into any of these actual consumers. And uh, the entities like that read the data, there can be multiple consumers as well. So each of the consumer, those can be individual consumer as well, or if we want to read the data also in parallel, so we can create something called as consumer group. So within a group, if we have multiple consumers, then those consumers will read the data parallelly from different partitions, and then they can store their output into a single system. So if multiple consumers they belong to same consumer group, then they will read a subset of the incoming data and then write it into the output. If any consumer is not part of any consumer group, or they are part of different consumer groups, then they read like the data parallelly, but they read their own copy of the data. And the numbers that we see here within a partition, these are called as offset. So whenever, let's say, a first message will come from the producer, it will go to, let's say, the partition 0, it will go into 0 position. The next message can go to the 0 position in partition 0, sorry, partition 1. The next message can go here, and the next message after that it will go to this first position, first position, first position, like that. So that is how the data is distributed across these partitions. Ideally, it is distributed evenly, like I explained, but practically there can be couple of offsets into one partition, then to other. So practically things are little bit different, but overall things are in parallel. So whenever a consumer read the data from these partitions, they read based on these offsets. So first it will, let's say, read the offset 0, then offset 1, offset 2, offset 3, like that. And internally it keep track also up to which offset it has read the data, so that next time when it is reading the data again continuously, then it knows up to which point it has already read the data, and from that point onwards it will start. So this offset is also very important concept to know, so that we know how exactly it tracks how much data it has read and from where it is getting started. So these are all the core concepts of the Kafka architecture. I hope these are clear. Just to summarize, producers they produce the data, then they publish their messages into a topic. A topic is the logical entity like a table in a database. And within a topic, the data is parallelly stored as partitions. And within partition, the data is stored position wise, one event per position. That position is called as offset, and the actual storage of data within the Kafka cluster is stored into brokers, which are like the nodes or the server systems where we connect and read the data. And then to read the data out, whatever is reading the data, those entities are called as consumer. Consumer can be individual, or there can be group of consumers as well, which can read the subset of the data, and then the data can be sent into any output system or whatever we want to do. So now, as we understand each and everything, now we will go ahead and set up the actual Kafka. And where we will set up is in the Confluent. So Confluent, it is the name of the company which was founded by the same people who built Apache Kafka when they were in LinkedIn. So in 2014, there were some people in LinkedIn who actually built Apache Kafka, open sourced it. Those same people, they founded this company Confluent, and that is why whenever it comes to streaming, this Confluent Kafka is the most famous and reliable one. So this is the one we are going to use. So to start setting up Confluent Kafka, what we will do is we will simply search for the term Confluent. And the first page that will come will be the official Confluent website. So we will click this try Confluent for free. And once we do that, this is our sign up page. So we can enter our email IDs and all, or we can sign in with Google. I will use this option because I have a Google account. Then you can select any of the Google account that you have, which you want to use for the sign up part. Now it is asking for some permissions, which I will allow. Now it is asking for some more information. So company name, we can provide anything. We don't want the emails. So I will simply click on submit here. So after submit, this is the page we are getting. I will simply skip this piece. This is kind of the survey. So you can select anything that you want. So we are exploring it. So these options, these are for kind of survey purpose. It doesn't matter. Here, this says like create your first cluster. So this cluster name, it's not that important. We can leave it. Or if you want to customize it, you can do it. Here, this region we can change to the nearest region that is there. For me, as I'm in India, I will select Delhi, but feel free to choose anything that is near to you. After that, it is asking for credit card number. But instead of that, below we see a option like do you have a promo code. We will I have a promo code that works without any credit card details. So we will click here and you can also use this same code. I will put this code in the description of the video. So this is the promo code which is there, and I'm going to paste it and then click on save. So it has been successfully added. And now it says like cluster is already created. Now it is saying like, do you want to use sample data or we want to use our own data? So we will use our own data here. And now we are getting these options. So this one I don't exactly remember. Let's try this one if it works. So, okay, we don't want to build any client here. So what we will do is we see here, like we have home environment. This was our cluster. So I will click on this cluster. Now we are on our cluster page. And if by any chance you forget this option or you are not able to figure out, you just click on this home icon here, this Confluent icon, and then also we shall be able to find our cluster here. So here we can go to environments, and here we can see that we have this default environment with one cluster. Here we can see that we have one cluster. This is our cluster. And if I click this cluster, it will take us to that very same page. So now as our cluster is ready, next thing we are going to do is we are going to create a topic in our clusters. So we will click on this topics, then click on create topic. Here we need to give a name to the topic. And the name that we are going to give to our topic is credit card transactions, because this is the data that we will be publishing and then consuming from here. And then this is the number of partitions, like the parallelism that we were talking about. So this one we will leave default, but it means that it is going to have 6 partitions. And this option, it says like enable infinite retention for this topic. So this is like by default it is disabled. So the data, it will be stored for some default period of time. But if we want to store it infinitely, then we can enable it so that the data, it is never deleted once it is published here. But uh, that is not advised for production scenarios. And if we go to advanced, we can even configure what shall be our retention time. By default, we can see it is 1 week. So like that, like these are some advanced configurations that we can make, but we don't need to change anything here. This was just for the knowledge purpose. So we just need to put our name to the topic. Rest everything we will leave as default, and then we will click on save and create. So now our topic, it is successfully created. That's it. We don't need to do anything else. This contract and all, we don't need to add it. We will skip it. So now our topic, it is ready to be send data to this topic and then read or receive the data from this topic. For that, what we need to do is we need to first send some data to this topic, and to send and receive the data we need connection details, obviously, right? So connection details where we can find is, if we go back to this cluster part, then we will need to generate API keys as well. Before API keys, we also need this bootstrap server. So this is the link to the server so that it can come and connect to our cluster. And this link I'm going to copy here and then paste it to a notepad so that later on we will use it. And we will also need the API keys. So I will click on API key and then click on create key. Here we will click on next, and then this is our key and secret. So both of these we will need. So this is our key I have copied. So key is this, and then secret or password, whatever we call it, is this. So I have pasted here, and then we it says like download and continue, because later on these may not be visible. So it is important to take a note of these so that we can use these later on. So it has been downloaded here as well. So that's it. Our keys are ready. And these keys, like, even I'm not going to hide it, but I'm going to delete my cluster before I publish the video. So don't spend time copying mine. So you shall go ahead and create your own cluster and try out on your own environment. So now, as we have all the connection details, next we are going to put some data to this topic. So for that, I have created a producer. So let's check it out. So for that, I have created a Python Kafka producer. So this is the folder that I will include in the GitHub. So you will see the folder in the link that I will provide. So this entire thing we will need to run it from VS Code. So you need to install like VS Studio, like, sorry, Visual Studio Code, which is free. So after installation, we need to simply open it, and then we need to go to file, open folder, and we need to open that folder Kafka producer. So we need to select this particular folder Kafka producer and click on select folder. Then it will open this folder. So I have already opened it. That is why it is showing like this. And in this folder, what we need to do is, let me close all these files first. There is this environment file. So if we go over here, we will see that there are options for bootstrap server, API key, secret, and the topic name. So these details we need to provide, which we had copied from there. So this is our bootstrap server. So I'm going to paste it here. Then this is our API key. So I will provide the key here. Let me paste it. And this is the secret that we had brought in. So I will put the secret here. And topic name I have already provided. In case if you are using any other topic, then you can provide that topic. And these other things you can leave as is. These are some configuration I made for this code so that we can control how many transactions it is generating, how much fraud and total customers and all are there. These things you can leave as is. So after putting these details, I will put press Ctrl S. So these are saved. Now we will need to run it. But to run this environment, we need to set up a like virtual environment and then install these libraries as well. And all these steps we don't need to do manually here. So in VS Code, we can directly do all these things. So we need to click this show run commands. Then this option will come, Python create environment. We will click create, and then it says like a quick create. So we will select this option, and to use this option, like any of the Python shall be installed in your laptop. So if Python is not there, that you need to install first and then come here and do this. So now it is setting up this virtual environment. So, and now it is installing the packages as well. So whenever it is setting up that environment, so this folder is created, and this is where it will do all this stuff it want to do. So now let me pause it until this environment is set up. So now the environment is set up. The pop-ups are gone now. So now the we will be able to produce some data. So for that, I have created these three files. Producer normal, which will produce normal transaction data without any fraud. It will simply send it, and then it will send some fraud transaction data, and then this is another like a fraud card related data. So these things we will see. For now, we need to just test if we are able to send our data to the topic or not. For that, we will use this producer normal.py. So we can, there are two ways to run it. We can open the file and simply click on this run Python file option. So it will automatically run the file for us. Looks like it didn't start. Let me try one more time. So now it is trying to make that connection, and we can see it is saying the data has been produced. So each and every line here, it is sending some data. So now I will put Control C so that I cancel it, because some data it has sent. This data we will be able to use it, and later on we will come back, send some more data so that we will see in real time how we are able to read it. But if these statements are coming properly, it means that the data has been produced and it has been sent to the topic that we had created there. And how it was able to send? It was based on these environment details. So on this server, using these credentials, it sent the data to this particular topic. So now our data is published. It is ready to be consumed. And we are going to consume the data using Spark streaming. So let's check it out. So we are going to use Spark streaming in Databricks, and Databricks it comes with a free edition. So if you don't have an account in the free edition, simply search for Databricks Free Edition, and then you will be able to sign up using any of your email account for free and then log in. It is a very simple step. You can do it. Once you have done it, then we need to go to login.databricks.com, and then we need to log in using our account. So this is my account which I have already logged in. So it will take me to the same one. So now this is our home page, and here we need to go to workspace. So in workspace we will create some notebook and everything. We will, whatever we will create, it will go to workspace. So for that we need to create a folder first for our project. So we will name it as FinGuard project. So now our folder is created, and we will click this favorite also, because we are going to work on it for maybe couple of days. So then once we click this favorites, it will, whenever you will go to workspace, then if you click favorites, it will be there. So directly you will be able to open it. Now we are going to create a notebook here. So this is the blank notebook created for us. And this notebook, we are going to name it as 01 because it is our first notebook. Then Kafka streaming test. Because first we are going to test it properly, then we will use it properly in the Spark declarative pipeline. So to consume the data from that topic, first thing we need is the connection details. So for that, we need the bootstrap servers. So bootstrap servers, it is going to be the same URL which we had copied here. So this is our URL. Then we have API key, which is our key. And then we have API secret. So this is our secret. And then finally we have topic. So our topic, it was the credit card transactions. So these are all the connection details that we have. So now using these connection details, we are going to read some sample data. So we will call it sample batch. So first what we are going to do is we will not read the streaming data directly, but we will read the batch data first from that streaming source, so that first we understand the normal batch reading, and then we will understand what option is changing when we convert it to streaming. So for that we will do spark dot read dot format. Format is going to be Kafka, because we are going to read from Kafka here. And then we are going to provide some options. So what we will do is we will put it in a bracket so that we can use multiple lines here. So this bracket we will close here. After that we need to provide dot option, and within the option there will be a key and there will be a value. So like this we are going to provide multiple options that are required to make this connection. So let me copy paste it multiple times so that every time I don't have to type. And looks like it was trying to run it. So for now, ignore the error. So, or I can clear the output as well so that it is not confusing. So format is Kafka. After that, the next option we are going to provide here, it will be Kafka dot bootstrap dot servers. So the value part, as you may have guessed already, it is going to be this particular value. So let me run this cell so that these values are stored and available. So this option, it is ready now. The next option we are going to provide is subscribe. And subscribe, it is like we subscribe to a topic, so that whatever is published to that topic, it will be subscribed and it will be received to us. That is how it works. So here will be the name of our topic, which is stored here. So now we have the server details, we have the topic name. Next is pending is the authentication details, how we provide the key, secrets, and all these. So this part is bit tricky, not exactly tricky. There is a very standard way of providing the API keys and secrets here. So those options I'm going to directly paste here, because remembering them it is not possible, at least for me. So these are the options we need to provide. And just to remove these red lines, let me just clear it out so that later on we will use this dot load also. So let's understand these options. So this is all about like providing the authentication detail. So here we are saying like which security protocol we are going to use. So there are different authentication protocols. So this one is like a simple authentication security layer. So this is the one we are going to use. Similarly, for you to use this particular protocol, the next set of options we are providing is like which mechanism we are using. So here we are using plain. That means the connection details we will provide it as plain text, and then we also need to provide something called as uh, JAS configs, and the full form of JAS is Java Authentication and Authorization Service. So this is a very specific like authentication mechanism which is used by Kafka. So we don't need to like understand each and every point here, or we can simply put these options and say that these are required to make the connection, or this is how we make the connection. But I wanted to explain in detail, so I explained. If you are new, you can just assume that these three lines are for authentication. And then there is another thing, that to provide these jas config, this also has to be provided in a standard way. So how do we provide this is like this. So this is a very standard mechanism that we need to type this exact thing, and then we provide the username as API key, this API key, and this is our API secret. There seem to be some typo. Let me correct it. So yes, this is the secret. So this is how we provide the API key and secret in a very standard way. And nobody can remember this. So we just need to paste this and change our API key and secret here. Let me run this so that this is also available. Okay, I didn't run it again after correction. So let me run again. So now this is ready. So now our connection, it is ready and we can read the sample data now. But before we read it, there is one more option we need to provide. So by default, what will happen is if we run this now, so from this point onwards, it will start reading the data from Kafka. But we want to read all the data that is currently available. So we need to play around the offset. So for that, we need to provide another option here, and that option is simple, like starting offsets, and the value for these option is like earliest. So earliest means like start from very beginning of the data that is available in this particular topic, and its default value is latest, so that whenever this is starting, after that whatever data is available, that data it will pick up. But as we are reading it as a batch, so we shall provide this option, or we shall provide the exact offsets from where we want to begin reading the data. So now all our options are ready. So let's go ahead and read our first data from Kafka. So now our data frame is created, but this doesn't mean like connection is successful, because this is a Spark follows DAZ, it follows lazy evaluation. So when we actually read the data, that time we will see. So first, let's see how many records, which records that are available here. So we will do a simple count, sample batch dot count. It will give us the count of records which are available. So here we can see that 61 records are available into our Kafka topic, which were produced by our producer. So here it has published 61 records when we ran it. So those records are available. So now let's see what exact data is available. So if we go there, and then we need to, what we need to do is we need to display this data frame to see which data is available. So we are going to display this data frame now. So this is the data which is coming. Here we can see that this is the key which we had provided in our producer. It was the transaction ID, but here it is available as binary. If I hover over here, it will say that the type of this column is binary. Later on, we will cast it to string to see the actual value. Similarly, the value is also available as binary here. So this value contains our actual data. Let me minimize this left section from here. And apart from this actual data, so all the data which is coming from which is being put up or coming from Kafka is always sent and received as key value pair. These two are very standard columns. So we provide a key, and in the value part we provide the actual data. In the key part we provide a unique key for each and every data point. And then we get some standard options also, standard additional columns also, which come by default whenever we read data from Kafka. So those columns are topic, which is the name of our topic, then partition. So if you remember, we had 6 partitions. So the partition number, it will be from 0 to 5 because it follows the 0 standard. And then this is the offset. Offset, what it means is like the position of this particular data point within that partition. So let's say from second partition, it was read from the 0, 1, 2, all these positions. Similarly, from first partition, it was read from these positions. So that is how these offsets and partitions, they provide exactly from where the data was being read. And this is the timestamp column and the timestamp type. It is like whether the timestamp column is available or not. This is the actual timestamp column, which is the event timestamp. So these are the additional columns that we are getting. So now to actually use this data, we need to obviously cast these two into strings. So now to cast this data, we will create another data frame. We can name it as casted, or let's say parsed batch. It is going to be like our sample batch dot, and then we are going to put a select statement, and within select we will provide multiple select options here. So first we will read the column, key column. So this is how we read in PySpark. So call key dot, then we use cast, and we want to cast it as string. So this call, this is again a function which is in there in Python. So by default it is not available. So we will need to import this. So we directly don't use import, we use like from. So it is coming here like PySpark SQL functions call. So it is automatically coming using Genie. I am just pressing tab. So as we have imported it, now it will work fine. So this will cast our key column to string. Similarly, we need to cast the value as well. So I will simply, oh, it is coming automatically. So I will simply press tab. So value also it is casting a string. Topic it is not casting. It has that intelligence that it knows that these are, there is no need to cast these. So for you it may or may not come. If it is not coming, you can type it. But for me it is coming. So I will simply press tab. That's all. So now all the columns has been selected. So and these two has been casted. So which is the more important part. So now I will run it, and then I will display this parsed batch. So it took couple of seconds, and now the results are here. This time we can see proper data here. So this is the data which is being generated from the producer that I have created here. And this is the data it is passing. Like this is the transaction ID, customer ID, card number, merchant ID, and then many other columns which are there. And there is a transaction timestamp column as well. And out of all these columns, the transaction ID is unique. So that is what we are using as key column here. So this key and value are being passed from the producer that is generating the data. And this is how, like when it is converted to string, this is how it looks like. And this is the data it is passing. The other columns we were not making any changes, so those are available as it is here. And now let's say if we want to store this data into a table, so what we will do is we will take our batch and we will save it as table. So let's say this dot write dot save as table, and then we need to provide the table name. And in the table name we need to provide a complete name, which is three namespace like catalog name dot schema name dot table name. So for that, first of all, let's go ahead and create our catalog and schema. And for that, I will simply duplicate this tab, and then we will go to this catalog section here. And from here, I will click this plus icon and then click on create a catalog. So this catalog, we will name it as FinGuard, which is the name of our project. So catalog is created. Now we will view it. Within this catalog, we will create multiple schemas. So to store our bronze data, we will create bronze. So we will create a schema named bronze. And then this is where we will create our bronze tables. And let's go ahead and create for silver and gold as well. So these silver and gold, we will use them later on. Oh, sorry, silver already we created. Let's create gold. So if I open this bronze one and if I copy this name, this it is copied now. if we go back here, I paste that name. So it will show catalog.schema, and then dot, we need to give a table name. So table name, let's say it is transactions batch test, because still it is batch data that we are writing. So it is complete now, and this means our table it is created now. So let me go to the tab where we had created the schema, and if we refresh this from here, we can refresh, and now we can see our table that is created. And if we want to check out some sample data, we can click this tab. We need to select a compute, it will start, and then it will show the data. So after a few seconds, we can see the data. It is the same data that we saw. So our table, it has been created now. And here in this icon, we can see it is a table. And why I am showing this? Because we will see how this looks like when we create a streaming table also. So if we go back, so this is how like reading the data from Kafka and then writing it to a delta table as a batch data it looks like. So it will read entire data from that Kafka, and then it will write it into this table again. And if we run this code again, again it will whatever complete data is available in that Kafka topic, it will read, and then it will write into this table. That is how it will work end to end. Now, as we have understood like how it works for batch data, now let's understand how we can use it for streaming data. That is the main purpose of this video and this project itself. So I have copied the code that we had from above to create this batch, and in this time instead of batch or sample, we will call it as streaming data frame or streaming df. So for that, instead of spark.read, we need to mention spark.read stream. So this becomes a streaming data frame. And do you know what other changes are required to make it as a streaming data frame? Nothing else. So this single word, it will change it from a batch read to a streaming read. But this is not the complete picture. While writing, there are other multiple options we need to provide. Then only it works end to end. But for the reading part, only changing this from read to read stream, it will create a streaming data frame. So let me run it. It will simply create a streaming data frame. And now, as we already know that we need to transform some of the data, and we need to do this transformation here. So I will copy this, and then we will make the same transformation here. And before I do that, I want to tell that this is a streaming data frame, so we cannot display it. It will throw an error if we try to display this. So if you try it out and it fails, don't be worried, because this is a streaming data. It is expected to be continuously reading and then writing. So displaying it becomes problematic. So that is why display on streaming data frame is not supported. So how we will come to know whether things are working? We will write it into a streaming table, and then we will check out the data there. So this is the same data frame. So let me change the name here so that now it will perform the same transformation uh, on the streaming data frame, and then it will be parsed instead of batch. Let's call this also streaming df. So now this will become our parsed streaming df. And next, what we need to do, we need to write this into a streaming table. And the options to write the data as a streaming table are totally different. So we will not copy paste the same from above. We will write on our own. So first of all, we need to provide format, which is delta. By default also it is delta, but it is better to provide that. And then we need to provide output mode. So output mode for streaming data, it will be append mode, because we want to append the new data as and when it is coming. In very rare cases, it may be complete mode also, where we want to replace complete data. But for streaming data, like append mode makes more sense. So this is our append mode. And then let me press a new line here. The next option that we are going to talk about, it will be a checkpoint location. As you can see, it is coming automatically here. So I will simply press tab. And for now, I will remove these other options as I will explain them step by step. So checkpoint location, it is a location in our DBFS. It can be any location which is mounted or created as a volume. This is the location where it will store the progress. So if we run this streaming data once, it will read the current data, write it into table. Next time when it will run again, then it need to keep a track like up to which offsets it has read. From there onwards, it will read the next time. So to store that progress, it needs a checkpoint location, and we will specify this location. So to specify this location, we need to create a volume. And to create a volume, we will go to our catalog tab. So this is our catalog. The FinGuard is our catalog. And then we will create a new schema here with the name source. And this source is our new schema where we will create a volume. So when we will create this volume, we will name it as transactions. We can give it any name, it doesn't matter. And you will notice that here we are creating a managed volume. So this volume is managed by Databricks itself. And we can also create an external volume which can point to a Azure Data Lake storage or S3 or Google storage anywhere. So the actual location can be on any storage account as well. Here we will use managed volume for simplicity. And now our volume is ready, and this volume is like a directory. So in this location or volume, we will create a directory or folder that will be our checkpoint. So this will be our checkpoint location. So now I will copy it from here so that it will copy this complete path. Then we will go back to our notebook and we will replace this path. So now this is where it will store the checkpoint location. And before we see other options, let me wrap it into brackets so that these red dots go away. And it is not going away. Looks like I forgot to specify the write stream. So here while reading we specify like read stream, and while writing we specify data frame streaming data frame dot write stream, and then dot format and other options. And then the next option that we are going to provide, it will be dot trigger. And in trigger, like there can be different options. So the option that we are going to use is available now equal to true. I will explain other options also. So this is the option that we are going to use. So in terms of trigger, apart from available now, there is like another trigger also supported, which is uh, processing time. So in the processing time, we need to provide some time as well. So for example, here we specify that 10 seconds. So what this will do is it will keep running the streaming job and it will process the data every 10 seconds. So whatever duration we specify, so after that many seconds or minute also, it will process the data. So then it will process the data in micro batches. So all it will be similar to batch processing, but because this is doing every second or every 10 second, it will kind of become a streaming data. So this is the processing time trigger. And in Databricks Free Edition, in this compute, which is serverless, it will say that this trigger is not supported on this compute, because this is something like currently they have not allowed. But if you have like a paid Databricks, then it will allow it. So there, that is why this one we will not use. We will we will use like a continuous processing that is allowed when we will go to the declarative pipelines. But here as a Spark streaming, it is not supported. So the trigger which is supported is available now. And what this does is instead of like running it continuously, it will run it only once. So available now equal to true, what it means is that load all the new data that is available now. So if we run it for the first time, it will load everything that is available. If we run it for the second time, it will check on this checkpoint location what data it has read previously. And that point onwards, it will read the new data that is available now and then stop. So that is how this trigger will work. And then the final option will come, that is to table, where we specify the table name that we want to create. And the table that we want to create, it will be in our FinGuard only, FinGuard bronze, and then transaction streaming test. This is the name we can provide. It has suggested automatically because we had created transactions batch test. So this time we are creating streaming test, and this it covers all the options. And when we are writing streaming data, it is better to capture it into a another variable, because whenever it is writing any streaming data, we get a query id as well. So if I print it, uh, we can print a message like query id is this. So let's see if it is providing it automatically with query id. And then uh, it is providing, normally it is available as dot id simply, and that's it. So this id, it is sometimes available for debugging and tracking purpose. So because this is available, I want it to show, otherwise this is completely optional. Only this much code, it will run fine. So this, it completes our streaming writing code, and now the code becomes end to end. So we are reading the streaming data. Here, we are creating a stream. We are performing some transformation, which is casting operation. Then we are writing the stream. So now let's run this code and we will see it running end to end. So now it is saying query has been started. It is currently running. And this is the query ID I was talking about. So this ID is unique for every time it is doing some processing. And now we can see that the processing has been completed. So let's check out our data now. And here we can see the data. It has been written successfully. It has 61 rows which are there available in the producer. And if we go to the schema here, which was the bronze schema, and if I refresh it from here, we can see that our table has been created. And this table also, it is not marked as streaming table. Why? Because these are marked by Databricks inbuilt functionalities, not by Spark streaming. We will see the difference. We will use the declarative pipeline, but this is where our table has been created. And now let's explore the checkpoint location also, so that we understand how the progress has been tracked. So if we go to the volume which we had created, the transactions volume, this location we had specified for checkpoint. And here we can see that it is storing some metadata, commits, offsets, source related information. So different information it is storing. And the one that where we are interested in, it is the offset, because we want to see how it is storing the offset. So this is a small file. I will simply download it. And then if I go to my downloads and if I open this file in a notepad or something, then this is where we will see the offsets being stored. So this is our topic name, and then these are the offsets. So what it means is, like, from 0 partition it has read 11 records, 1 partition it has read 7 records, second, like partition number 2, 3, 4, 5. So 0 to 5, 6 partitions, and it has read these records like 11, 7, 6, 11, 9, and 17. If we sum these up, it will come up 61. So that is how it now it knows that from each of the partition how many records it has read. And next time whenever it will read the data, So it will read the data this point onwards from each of the partition, and then it will know that this is the new data. So now we will try to write some new data and we will see how it is being put up. So I'm back in my VS Code, and earlier I showed the option to run it from top, like if you open and run it from here. The second option I was talking about is from here. So if I press the up key, it will show the script which was run previously, which is this producer normal. And by default, it used the complete paths here. And if you don't want to use this, simply what we can do is we can say Python and then the name of the file. So in our case, it is producer fraud, not fraud, like producer normal. This is the file we want to run. So like this also we can run it. So we will put some, if put a few extra records, it is putting. Now I will press Control C so that it is cancelled, and we will see if now it is reading these new records only. So now I will go back to my code and then I will run our streaming write again. And we are not running the reading part again because Spark it runs a DAZ operation. So it will store only the reference and the progress is stored here. So now it shall be able to check based on those checkpoint location and it will read only the new data. So now it is completed. So previously it had 61 rows. Now let's see how many rows it has. So this time we can see now it has 79 rows. So the extra 18 rows which were written here, those has been read and those has been appended here. So that is how using this trigger type available now, it read only the new data and then it wrote into this table. So this is how like the streaming processing looks end to end in terms of Spark streaming. And this Spark streaming, it is not specific to Databricks. It is like Apache Spark streaming. So whatever platforms they support Spark, there we can use it. Like we have Synapse, we have MS Fabric, and even if you use open source Spark, there we can use it. But as we are using Databricks, and Databricks, they have the people who built Spark. So on top of this Spark streaming, they have provided some advanced and additional functionalities that we can use for Spark streaming and batch processing both, but in a easier way with some advanced settings, advanced options that we get. And those things we get when we use the Lakeflow Spark Declarative Pipeline. This is the name they have given. Previously, it used to be called as DLT, Delta Live Tables, but now they call it as Lakeflow Spark Declarative Pipeline. So when we will use that, we will see that many of these options will be taken care automatically by Databricks, and we will need to write fewer code. We will get data quality checks capabilities, and we will get it more managed way where we can monitor in a better way. So these are some advantages we will get if we use the Lakeflow Spark declarative pipelines. That is why now, as you understand the base, how open source or the normal Spark streaming works, so now we will use the same thing in Lakeflow Spark declarative pipeline and see what advantages we will get there. And then there we will build it completely and we will build the rest of the project there itself. And before we do that, uh, we will store these credentials also securely, because when we work on production projects we never store credentials like this. So we store these credentials in a secret scope where we store them once. We can use them anywhere in a secure way. So first let's go ahead and store these credentials in a secret scope. And for that I have created a notebook already, because there we need to use secret scope APIs and all. And normally these are done by the admin people or senior architect people. But I wanted to show the proper use case of credentials, so I created this notebook. The same can be used by you. So here, first we need to provide a name of our secret scope where all our secrets will be stored. The name we are going to give is FinGuard-scope. So I will simply run it. And you can use any other name if you want. And then because we will be creating the secret scope and secret using APIs, because we creating them through the UI, it is not there in the free edition. So we will be using the API, and to do that we will need token for that. So this cell, it will automatically take our current user, generate a token and store them into the variable. That is what it will do. And here we are saying that the backend type, it is Databricks. It can be Azure, Key Vault, or the other cloud-based services as well. But here we will be storing them within Databricks itself. And after that, when we run this particular cell, it will create the secret scope. I have already created mine when I did it previously. So probably it will say that it failed to create because it is already there. If you are creating for the first time, it will create for you. So now as the secret is created, sorry, scope is created, then we need to create our secret inside this secret scope. And there we want to store these server topic key and secret details. So let me copy them from our other notebook. So these are the details we will be specifying there. So I'm pasting it into a new cell so that I can copy paste them and replace these older values that I had previously. So yeah, this is our secret. Sorry, that was the key. This is the secret. And topic name, it is the same only. So I don't need to replace it, but we need to provide it for sure. Now I will delete this cell. So now what it is doing is it will take these four values and it will create a JSON out of it. In the JSON, it will store them as bootstrap server, topic, API key, and API secret. And then it will create this as a JSON string. So it is created. So if I try to print this, it will print it as the JSON. And that is what we will store it as a secret, this JSON. And to create a secret, we have this API called secrets slash put. And there we are providing our scope name, the secret key name. This key is the name of the key, Kafka connection details. I'm providing it as a hard coded values here. And the same key we will use later on to retrieve these secrets. And the value part, it is this JSON that I showed here. So this is the payload we are providing. We are making the API call and then it will create our secret. So if I run it, it will say it is created successfully. I had previously also created, but it is replaced when I ran it again. This for secret part, it doesn't throw an error. So now it is like the secret is created inside the secret scope with these details and it is ready. And if you want to confirm if it is working properly, so this is the command we use like dbutils.secrets.get that we will use in our code also to get these details. And then the name of the secret scope and the name of our key. Then it will retrieve the data and that JSON it will parse it and then print it. So it has run successfully and we can see that it is able to retrieve the data, that JSON from the secret, and then it is able to print that. In production projects, never print these. I just wanted to print to showcase you that these values are coming properly. So now our secrets has been stored successfully into the secret scope. So from there we will use it. And then we have a next cell also where we will put a secret about Gmail API key. This we will cover later on when we will come to email notification piece. But for now, like only using these secret is enough for us. So as we have stored these secrets, next let's understand how we can read these secrets and then use in our code. So for that, we will go back to our original notebook. I will comment this cell so that it will not be used anymore. I will add a new cell so that when you try, you can still use it. And then here we will use like Kafka connection JSON. So this one we will be reading it from our secret. So db utils dot secrets dot get. And the name of our scope, it was the FinGuard dash scope. FinGuard dash scope. This was the name. And the name of the key, it was uh, the Kafka connection detail. So let me copy paste that so that there is no typo in that one. So this is the name of our key. And here for the key part also, we need to specify that this is a key, then it will work. So now it will read that JSON as a string, and then we need to parse that JSON. So what we will say is like Kafka, we will call it as config. This will be JSON dot loads, and it is automatically coming up. So I will press tab here. I will remove these for now. So now we can say that like the Kafka config is there. And now we will need to read these one by one. And this Kafka config, it is kind of a dictionary now. And this dictionary, it has all these four values. So this value, it will be if I paste this and if I type, so it is automatically coming. So if I simply press tab, it will say that these values are there, including the topic as well. So I will press tab again. So topic part, it is kind of hard coding, but in our case, we know that that is there in the Kafka config. So we will read from there itself. So now it will read all those secrets from our secret scope. So this one, we don't use this in production scenarios. So let me run this so that it is able to read that scope, and it threw an error saying that the secret does not exist. So there shall be some typo. Let me double check again. So it is details, not the detail. So looks like I was not able to copy it properly. Let me run it again. So now it is able to read it, and these connections has been set. Now with this new API key and secret, let me set up this JAS config, and then batch part we will not run again. We will directly run our streaming part. So this stream has been created now after I run this with the new details. The transformation, it is done now, and then we will write it into our table. But before that, let's write some data again so that we will know that the new data is being written. So I will press up, it will bring in the same command. Then I will press enter. So it will read. I will press Control C. So only these three records it is writing. And then I will go back. I will run our write query now, and it is still running. So in free edition, sometimes the resources in serverless are not available. That is why sometimes it is stuck, it takes longer time. So you can interrupt it and run again, or you can let it run for some time. And looks like this time the timeout happened. So I will run it again. And if it is taking very long, then we will go to the next step, and then we will come back here and then check it out. And looks like this time also it is running for longer. So to save my time of recording, we will continue building with the uh, a Spark declarative pipeline, and this piece we will check later on. But I think you believe me that it will work fine. So to build the declarative pipeline, we have different options. So one of them, it is that from here we can create it. So if I click here, if I click create, and then we need to click this ETL pipeline. So it will create a pipeline in that same folder. And when it creates, creates a different type of UI. This UI itself, it is the Lakeflow Spark Declarative Pipeline UI. So from now onwards, like a Spark Declarative Pipeline, the short form we use is SDP. So whenever I mention SDP, it is like Spark Declarative Pipeline. So for this SDP, we can see this is the pipeline part where it is showing only this pipeline related table. It has created a sorry this pipeline related files, and if we go to all files, it will show the main workspace. So these were the two notebooks we were working previously, And this is the new folder it has created for this pipeline. So if I open it, we will see the same thing that we see here. But while working on SDP, we will see that this pipeline section is more useful, or it is like easy to work with. And then this pipeline, we will rename it. We will name it as FinGuard Streaming. This is the name that we will provide here. And this folder name also, we will rename it with the same name. So it says rename root folder. We will name it as FinGuard Streaming. And then it has created this transformations folder, but we will use our own folder here. So we will create our folders based on our medallion architecture. So first we will create a folder named bronze, and then this folder we are not going to use. So this folder we will delete it, and looks like it will not let us delete because at least one folder shall be there. This other folder which is there, so by default it will be ignored for execution. So to include this, we need to click this include folder as pipeline source code. Then this folder will be considered. And this option now it will allow us to delete it. And why we need to do that? Because this is also a good functionality that if some folder or pipeline we are doing for testing and if we don't want to run, we can include or exclude them as pipeline source code. So this is the bronze folder. Now we will create our file, and this file we will name it as uh, transactions bronze. So I will remove rest of the name, and .py we need to keep it. So now this is where we will write the code for Spark streaming or specifically for SDP, and we will see how it is different from the normal Spark streaming. So to start with the code, we will first need to import something. So from PySpark, we will import pipelines as DP. In pipelines, there is a E as well. So this is our declarative pipeline, and this is a decorator as well. So how do we use a decorator is @DP, so that it will know it is the a standard like SDP decorator, and then dot table. And in this table, we need to specify the name of the table that we want to create. So it take different values like name, and this name it is the name of our target table that will be created. So our target table we want to create it as FinGuard dot bronze dot transactions. This time there is no test or something. We want to create it with the name transactions. And then there are some additional properties as well. For example, comment is there. So there we can mention like what is the purpose of this. And here it is comma, not a dot. So in the comment, we can mention what is the intention of this particular table or this particular file. So we can say like transactions raw stream data ingested from Kafka. That is what we will store into this table. Now with this decorator, we will create a function like diff. Then we can name the functions as like transactions bronze only. And now after this name of the function, we will say what it will return. And there is a standard that it shall be returning a data frame. So this data frame, as of now, we have not yet imported. So this also we need to import this like from PySpark.SQL, we need to import data frame, and it is SQL dot data frame. This is how we import it. Now it is imported. And here we need to return a proper data frame, which is our streaming data frame. So the structure until here, it is very standard for SDP, and we will see like what advantages we are getting with this proper structure. So now what we need to do is we need to write our streaming code here. And for that, we will reuse the code that we had written already. So we will go there, and first we will copy this code which will read our secrets from there. So I will copy paste that same code here. This import piece, I will cut it from here. I will keep it at the top because all the libraries, we shall keep it at the top. I will select it, press tab so that the indentation is properly. It has to be with some space. This is the standard Python. And after we have our secrets ready, then the next thing we need to do is we need to create this jas config. So this code also I will copy from previous notebook and put it here. And next we will need to write our streaming piece. So as we are back in the notebook, let's confirm if our previous code was successful. And looks like it's still timed out. So either the Kafka is not available, or as we were trying it for the first time after putting our secrets. So maybe we may have made some typo as well. So let's confirm that piece first. So let me copy this. I will go to our setup secret notebook and we will try to compare if we are using the right thing. So this is starting properly. Oh, looks like here we missed it too. So it was 9092, but we kept only 909. So now I have added this 2, and we will add this secret again so that it can connect again. So earlier it was trying with some different port and it was not able to reach there. And it is saying JSON not defined because it was imported in earlier cell. So let me run these above cells again, and secret scope it was already created, only secret we will need to create again. So now this JSON is ready, it will print it again. So now it is 9092. Let me put this new secret. Now this new secret has been put. Earlier it was 909, now it is 92. So now our streaming code shall work fine. Let's run it one more time. So this is run. Now let's run the streaming code directly. So this is our streaming code. Let's run it. Let's run this as well. And this time it is successful. It ran quickly. Now let's check out our table again. And here we can see now it has 89 records. I was expecting like 3 new records on top of 79, but it has inserted 10 records. Let me double check. So I thought it has written these three, but looks like this is some line. It has written these seven plus these three. So total 10 records. So we are good. So those additional 10 records has been written, means our code is working fine. So now let's take this streaming code to the SDP pipeline. So where it is? Yeah, this is our streaming code. So this is reading the stream. So let me copy this from here, and then we will take it to our SDP pipeline. So after that, I will provide it here. So this is the streaming piece. And once we have this streaming data frame, then what we did was we parsed it. We converted these into timestamps. So let me copy this code as well and let me put it here. And this import statement, I will keep it at the top. So now this piece is also ready. And I also want to add a new column here as the current timestamp, as the ingestion timestamp, so that it is available for better tracking. For that, we need to do something like f dot current timestamp, but yeah, it is coming here. And then we will name it as ingestion timestamp. So this will be the name, and here it will be available as the current timestamp. And this f, it is the function. So we will need to import that as well. So it is like from PySpark. dot SQL dot uh, functions as f. So this functions, it will be imported as f, and f dot current timestamp will be our current timestamp. So you will think like I am just copy pasting the code from there. So what is the advantage? So now comes the advantage part. So as you already know that for writing this stream, we had to provide these modes, the checkpoint location, the trigger type, the table name and everything. But that one advantage of this is that we don't need to maintain any checkpoint or anything, any location, nothing. Simply what we need to do is we need to return this data frame, and that's all. So that is how the writing part it has been simplified. How it will work internally is that it will return this data frame. This data frame will be written into this table as a streaming table automatically, and the checkpoint and everything will be maintained automatically by Databricks. We don't need to maintain anything there. And when it comes to the trigger type, so for that we get the trigger type here. So if we go to the settings, the pipeline mode it is triggered, so we can schedule it. We also get a continuous mode where it will run it in the actual real runtime way. So that is something we will try later on when we will build the silver part, and then we will see the end-to-end streaming data flowing. But for this particular table, that's the entire code that we need. So now for this table, the code is ready. So we are going to simply go ahead and run this code. And to run that, we simply click this run pipeline. And there are other advantages also we get. Oh, before that, let me select the catalog and schema name. So it has some default catalog and schema we need to provide. So it will be FinGuard and Bronze will be the default one, and then we need to run the pipeline. This is where we can also configure the default catalog and schema names. Currently, it is waiting for the resources. And this is another advantage that we are getting a good monitoring screen here. We can also apply data quality checks that we will apply in the later state, and also connecting different streaming table that is also made very easy when we go with these STP pipelines. That also we will see. And now the resources are available. It is initializing the pipeline, and looks like it threw an error. If we go, it says invalid syntax. If we click this jump to code, it is taking here. So it is saying, oh, so we didn't mention the import keyword. So in between here, we need to import functions as f. That is the correct, that is how we actually use it. Now let me run it again. So, and this time it threw another error. It is saying find guard is not found. So again I made a typo. I will correct it and then run it again. And this time looks like syntax wise things are fine. So it is currently setting up the tables, and now the pipeline has been started. And if you are also using the free edition, sometimes the waiting for resources it may take a lot of time also, depending on the time of the day when you are running. So if it is taking a lot of time, you can stop and try at some other time. That is how it works. And this pipeline, it is executed successfully now. We can see the success here. It ran for 23 seconds. It wrote 89 records in the output. And then if we click here, view in catalog, so then it will open a new tab and show us that table which is created in the catalog directly. So this is the table which is created. If we go to sample data, we will check out some sample data of this table. And if I scroll on the left side, so this is the icon I was talking about. So now, because it was created by SDP pipeline, so now it is marked as a proper streaming table. So Databricks, it will also know automatically that it is a streaming table, and internally it is managing its checkpoint and all the things internally without mentioning or doing anything. And here we can see the data that has been written into this table, the key, the value, the topic, the partition, offset, timestamp, everything. And this is the ingestion timestamp that we had added from our side. So now this is how our raw data looks like. And next thing what we need to do is we need to parse this value, the JSON value, and we need to create proper columns so that we can use this data properly. So to parse this raw data, we are going to create our next silver layer where we will parse these columns and write them into their individual columns. So let's go ahead and do it. And for that, I'm back in our pipeline. Here again, I will click on create and I will create a separate folder for silver layer. And here we will create again a new file. And this file we will name it as transactions underscore silver. And now the top part, it will be almost same. So I'm going to copy it from here and then we will use the same here. So imports and all, we will keep it the same. Looks like it is gone. Let me paste it again. And then this time the table name will be same, but the schema name, it will be different because we will create it in silver layer this time. And the comment, we will name it as like parsed and cleaned transactions data. And this function also, we will name it as transactions underscore silver. And in here, now we need to write our logic. So first of all, we will read the bronze table as a streaming table. So we will name it as bronze df. And then we will say like spark dot read stream dot table, so that it will read the bronze table as a streaming table. And the name of the table, oh, it is guessing automatically. So this is the name of our table. So this is our bronze streaming data frame. Now we will transform it. So we will say transformed df equals to this bronze df, and then we will say dot select. And in the select part, we will specify multiple things. So first of all, we want to parse our JSON, right? So for that, we will say that we have imported the function as f. So there are multiple functions inside the functions. Then we will say from JSON. And here we need to specify the column. So we will say our column, it is value only, like it is guessing. And then we need to specify a schema. So for now, I will mention only the word schema, and then we need to give it as a alias. We will name it as maybe data, like it is suggesting. So, but before we proceed further, we need to specify a schema. So whenever we are parsing a JSON, the best practice it is to specify a schema. So what we will do is we will copy the sample data and then we will create this schema. So we will do it using Genie code. So here we will select this, then we will press this icon and we will say like create the schema based on the sample data this. So we will provide some sample data and then we will ask it to create that schema for us. And looks like it is trying to use like f dot schema of JSON. So this sample it has provided automatically and then it is asking to derive the schema from this. But this is not a best practice. So I'm going to reject this change. So I pressed escape because that is not what we want. So I will say like here, we will need to be more specific here. So we will say that schema and then we will say like create the schema is struct type and struct fields from the sample JSON then the JSON that we had copied. Let me copy it again. So now we are saying like create it as struct type and struct fields so that it will create it in the very standard PySpark way. So this time it is creating it properly. So I will accept this change, and now we can see that it has created this f.struct type. This is the standard way of creating schema. Then the field, it is creating each and every field, like it is a string, these all are string, amount is a double type. So it has specified each and everything. And this is the standard way of creating schema. Now this schema will be put up there. So what it will do is it will take the value column, it will attach this schema, and then it will point out all these columns properly. So now what it is doing is it is reading this data column as it will create it as a kind of dictionary. And apart from this value and this data column, what other things we need is the other column for tracking. For example, the Kafka topic, partition, offset, and these timestamps. So what we will do is we will say that f dot call, and then we will take the column, or it is taking automatically topic, partition, offset, and then we also need to take timestamp. So that also it is taking timestamp type, we don't need it. And then we had the column like the ingestion timestamp. So that is something we will take. And these column we will need to add alias so that uh, we will give them as some meaningful name, so that in silver layer these are understood properly. So instead of topic, we will say Kafka topic. And instead of simple partition, we will say Kafka partition. And instead of offset, we will say Kafka. So let's see, it is able to like suggest automatically. And then instead of ingestion timestamp, we will name it as bronze ingestion timestamp. So this is how we are going to select all these columns. Now this data column is available as a dictionary, but what we want is we want each and every value as a separate thing. So for that, what we will do is, uh, so I will press tab for now so that it is selecting all the columns and returning this transform df. And this is how we will return all these columns. Here, the data dot star, what it means is that whatever fields are there with this schema, so it will create each and every field inside data as a separate column. So all the columns will be extracted, and then those will be created as separate columns. And here we want to also add a current timestamp, so that we will name it as silver ingestion timestamp. So this will be additional column. Now we are returning this transformed df. So this df, this transformed data is being returned as a streaming data frame, and then this data frame will be automatically written into this table, like we understand how SDP works now. So now we will try and run this pipeline, see if it is working as expected. But before that, we will see that this is the mark. So it means like this file is excluded from pipeline source code. So by default, it will not run it. So we need to include this. So I will include this silver folder itself so that it is included going forward. So now it is included, and this will also run now. So now we will go ahead and run our pipeline. So I will click on run pipeline. And here looks like our pipeline failed, saying that SQL functions has no attribute struct field. So looks like this is a like mistake made by Genie code. Sometimes AI can make mistake for sure. So what we will do is We will import it separately, like from PySpark.sql.types. It is saying like import all these. So I just pressed tab and it imported all these separately automatically. Or simply what we can do is we can also mention star so that it will import all the types. But these are not available as f dot. So we will need to remove these. Or what we will do is we will simply say like we will use Genie code to remove it. We will say like remove f dot from all places here. So here looks like it has removed it, but the accept button it is gone. So sometimes it may be bit weird that we don't see that button anymore. So I will put escape for now. So the changes will be ignored. And this time I will try not to scroll. So I will do Control I and I will say remove f dot from all places. And this time without scrolling, I will first click on accept so that the changes are made, and looks like it has made the right changes now. And before we run the pipeline again, let's add one more thing, that is about data quality, which I just forgot. So when we use this declarative pipeline, so it comes up with the standard way of defining data quality checks. So how do we define is @dp dot expect or drop. So this is the standard word we use, like either this condition shall be satisfied or otherwise drop this record. So then we give a name to the DQ rule saying like transaction ID is not null. This is the name, it can be any name, and this is a valid SQL syntax as well. So the name we will give it maybe before this any other name. We will name it as like valid transaction ID. So this is the name of the DQ rule. This is the actual rule. So it shall not be null. That is the expectation we are setting. If it comes anywhere null, it will drop that record. And this is one type of rule. We can define multiple also. For example, oh, this is putting automatically. So I will just press tab and it says valid customer ID shall not be null, card number shall not be null, merchant ID shall not be null. And then there is another type of rule as well, which says like it can be either expect or drop or only expect and not drop. So we don't need to specify anything like not drop, but if we specify only expect, it will check it, and in the output it will show that the rule was failed, but it will not drop this record. That is how it works. So this is how we define these data quality checks, and when we run the pipeline we will see how the output comes. And in this rule, the rule is valid amount and amount shall be greater than 0. That is the expectation we are setting here. So this is additional functionality that comes ready to be used along with the Spark declarative pipelines. So now as we have defined our DQ rules and fixed the f dot that error, let's run the pipeline again. So now it has initialized the pipelines and looks like there was no syntax error. And now it we will see two transactions here, one for bronze, one for silver. So first it is running the bronze one because both of these are included in this pipeline. So it will always run every table or every file that is there. And here we can see that when it ran bronze, so it did not write any output record. And why is that? Because we already ran it. There are no new record pushed from our side. So that is why it is not coming. And on the other hand, on silver table, it has written those 89 records. And expectations, this is the effect of these rules that we had defined. We had 5 rules and it is saying 5 met. It means that all the 5 rules were met. If I click this, we see this that 89 100% records has been written, and all these rules has been satisfied. There were no failures, and this is the action it would take if it was there. So expect or drop, it will drop it, and amount, it will allow it, because it was only expect and not the drop part. And if I close this, and if we want to check out our table, the silver table that has been created, so we will click this icon here. It will open this catalog explorer and our silver table. And in our silver table, we can see all the individual columns inside the value piece, the JSON. It has been parsed and created as individual columns. So now let's check out the sample data here. And here we can see the silver table. So the data has been parsed. We have proper separate column for each of the data point, like customer ID, card number, merchant ID, name, amount, everything. It is created as a separate column here. And then these Kafka columns has been renamed like we did. This is our bronze ingestion time and our silver ingestion time. So all the columns has been created properly. And now we can say that bronze and silver layer for this Kafka stream has been built properly. And now let's try to run some incremental data. But this time we will run it in continuous mode, because we have done a lot of with this triggered mode. Let's see some real time data coming in, how it comes. So if I click this continuous and click on save, so this pipeline, it will start running in continuous mode now. It will start and never stop it until we stop it manually or something goes wrong. So till then it will keep running. So it is currently waiting for resources. In the meantime, let me show you this pipeline graph. If we click this, we can see that automatically it has detected the dependency, that first it has to run the bronze transaction one, and then it will run the silver transaction one. So due to this dependency, it will always run this one first, then this one. And like I was saying, in free edition, it can take time sometimes for waiting for the resources. So let me pause it here. And looks like it has found the resources. It took only around 2 minutes. Currently, it is initializing the pipeline, and now it is running. So by default, it will first run both the tables one after the other. And as you may guess, there is currently no data going to the producer. So it will not find any new data, and it will pause it after some time. So now it goes into the idle state as there is no data, but it doesn't mean it has stopped. It is still running. So without making any changes here, let's start producing some data, and then we will see some real time data flowing in. So I'm running our producer script again so that it start pushing new data. It has started pushing. And if we go back here, here now we will see that without making any changes, it will pick up that data automatically from that Kafka topic, and then it will start processing. So here it goes. Automatically, it started the bronze script first. It has started writing output record, and then silver also it started automatically. And we will see that the bronze part first it is coming here like 100 to 123. Then those records are going there as a batch. So as a micro batches, it is performing the end to end ingestion of the data. First, it is ingesting into our bronze table, then into silver table, after applying these data quality checks and after the parsing. So currently this is how the real streaming pipeline looks like. Our data, it is going in real time, then this is being read in real time, and it is being processed in both the bronze and silver layer end to end. And this pipeline, it will keep running until we stop it or we make any change here and there. So I hope now it gives a better sense how the end-to-end data flow looks like. So first of all, I will stop our producer script, and these records that it has put up, so many records. So it will keep processing them, and then once it has processed all those records, then it will go into idle state. So now after a few seconds, it has read all those records and it is again in the idle state. So this is how the end-to-end streaming data looks like. So now I will go ahead and stop this pipeline because we don't want to keep it running for rest of the development. And the trigger type also, for now we will change it to triggered, so that we make the changes, we add more scripts and then we run it whenever we want to. So here I would like to take a pause and then to add a checkpoint, right? So what we have done, we have set up our Kafka topic, everything properly. Our producer is sending the data in real time. We are getting the data in real time in bronze and silver layer and processing it end to end properly. So what I would suggest is that here you take a pause, you do a hands on all these pieces whatever has been explained so far. Once you are comfortable with all these pieces, then you move on to the next part of the demo, because that will be on top of it. So once you are comfortable with these pieces, then you will be able to understand the next pieces better. And if you are already comfortable until here, then let's move on. Now let's understand first what we are going to work on next. So far we have brought in the data from Kafka, which tested out Spark streaming, and then we have built bronze and silver layer with Kafka data. Now we are going to set up our first fraud detection mechanism. And for that, we will take one simple example of fraud. So, for example, if our transactions are coming, so as a customer, if I have set up a transaction amount, let's say it is 50K or 100K, it is a transaction limit in my account. And if any transaction has been performed more than that value, that means it is a fraud. So, that is the fraud we are going to detect. And for that we will need additional data now, because our current streaming data, it is having a transaction, customer ID, transaction amount and everything, but we will need the, for that given customer, what is the transaction limit that I have set up. So that kind of data, it is not a streaming data, the customer related data, that is considered as batch data, because normally that is stored in a Postgres or any other transactional system. So now what we are going to do is we will prepare our Postgres SQL with the as a free edition. We will put our customer data there. We will ingest that data as a batch load using Lakeflow Connect into bronze and then into silver layer as well, using similar Lakeflow declarative pipelines. And after that, we will join both this streaming and this static data. So we will cover this stream static join part. And using that, we will build the gold layer as well as we will detect the fraud. And then we will send the real time alert as a email. So this is the piece we are going to work on next. So for that, let's start by setting up our Postgres SQL. So for Postgres, there are a lot of different options we can use. Different companies, they provide their own hosted version of Postgres. One of them, a good one, is Neon. So I normally prefer this one if you follow regularly, because here the sign up process is simple. Using this, it has been made very simple. So if you search for Neon Postgres, this is the link that will come. You shall open it and do a sign up. Here we don't, the sign up process is very simple. We just need to like log in using our Gmail account or using our email ID. It is very straightforward. And once we sign up, then we will get a login page. And after login, this is like the home page that we will get. Here we need to go to this project section, and in here we can create a new project. And as you can see, I'm using the free edition currently, so I didn't add any credit card or anything. So here we simply need to create a new project. We will name it as FinGuard, which is the name of our current project. Rest of it we will leave as default. A region, maybe we can select whichever is closest to our location. So after selecting these options, we will simply click create, and our project, it will be created. A database has been spin up. Uh, and here you can see that the project that we just created has been selected. And then what we need to do is we will need to create some table now. So we will go to table section, and here we will see that currently there is no table at all. So to create a table, we will go to SQL editor part. And to run the SQL query, I have created two scripts, customer historic and incremental load. So these scripts also, these are included in GitHub. So you can directly use these. So I will simply copy the content, and then I will come here. I will delete this part and paste it and then run it. So this has been executed successfully. First, it dropped the table if it was there. It created, it inserted 1,000 records, and it did a commit on those records. So now if we simply do select star from customers, so this table shall be there. If we run the query, we can see that a customer related data has been inserted here now. So customer ID, customer name, gender, age, city, there are different details which has been added here. The one which we are interested in is this transaction limit. So for each customer, this limit has been configured, and if the actual transaction is more than this amount, then we will send a real time alert to email ID of that particular customer. So if you see here, I have added a static email ID, which is my own email ID, so that I can show the email that is being sent. So if you want to, you shall replace this email ID in this script. So you can simply find that email ID, this one, and replace it with your own. So if I put Control H, I can find and replace it with anything. So you shall use your own email ID. And amount part also, currently I am using this 100K everywhere, because sending some fraud transaction is easy while generating the data. That is why I am keeping it fixed. So now our table is ready. If we go to the table section, then here we will notice our customers table has been created. So this is the table that we are going to ingest into Databricks now. For that, we will need connection details. And for connection details, we need to go to settings. Looks like it is not here. Let me see. If we go to dashboard, yes, here we can see. So if we click on this connect option, we will see this connection string. So this contains the details that we will need to connect to this Postgres SQL. So I'm going to copy this snippet by clicking this button. Then I will go to a notepad, open a new tab, and I will paste it. So this contains like multiple things that we will understand how to use this in Databricks. So now to ingest the data from here, we will go to Databricks. So this is our Databricks page. And here we will go to the jobs and pipeline section. First, I will duplicate this tab so that I can still use the current tab. And here we will go to jobs and pipelines. And here there are three types of jobs we can create. So ingestion pipeline is the one we will use now to ingest the data. ETL pipeline, this is the Spark declarative pipeline that we created previously. From here also we can create the same. This job, it is for orchestration, running things end to end. This one we will use later on. So for now, I will click on this ingestion pipeline. And here we get all these options. From all these sources, we can ingest the data. So the one we are going to use is Postgres SQL. So this is the one we are going to use. So here, first of all, we are going to create a connection. And here, connection name, we can provide anything like FinGuard, uh, Postgres. That is the name I'm going to provide it. Then we need to provide the user, password, and the host name here. So for that, we need to go to this URL and get the details. So after this double slash, this neon DB owner. So this is what is our username. So this is what I will paste here. And after this colon, so this colon is not included in any part. And before this 8 the rate, this is our password. So I will copy this password. And after this 8 the rate, before this neon DB slash, so this is what is our URL. So this thing you can maybe take a screenshot and then refer, and then you can use your own. So just remember, before colon is the username, before @ is the password, and before neondb, not including slash, that is our URL. So these things I have pasted. Now I will simply click on create connection. So now my connection is created. It is not yet verified. It will be verified in the next step. So for now, it has been selected. I will click on next. Now we need to give a name to the pipeline. And this pipeline, we will name it as FinGuard Customers Ingestion. And then we need to select a catalog here. We will simply select our FinGuard schema also. We will select bronze one here. This is for like event log. So internally it tracks some events. So that is what it will do here. Then we will click on create pipeline and continue. So this step, it took couple of seconds. I had paused the video in the meantime. Here we need to provide a database name. So database name, it is going to be our NeonDB. So I will put it here and click on this plus icon. Now it will check in this database what all schemas are available, and then the list of tables. So it has these three schemas. And if we go to our Postgres UI, there we will notice that our customers table, it is available inside the public schema, and NeonDB is our database. So here, if we go inside this public one, this is where we will find our customers table. So we will select this table. Destination table name, we will keep the same. We don't want to change it. Cursor column, it is for incremental data load. So here normally we use timestamp kind of column, which helps while doing the incremental loads. So currently it is fetching the list of columns from source. So it is taking some time. Now it is ready. If we don't want incremental load, we can click this batch snapshot as well, so that every time it will do a full load. But we have a incremental column, so we will select this update timestamp. And in the primary key, we will select customer ID. So now our configurations are ready. We will click next. Here, this is the destination selection. So in destination, we want to create our table into bronze schema only. So it is already selected. We will click on next. And here it is creating a schedule automatically. So by default, it want to run it every 1 hour. We don't want to do that. So I will simply delete it, because initially we will run it manually. Then we will add some orchestration. And this is the failure notification. So on failure, it will send an email. We can keep it or delete it if we want. And finally, we will click on save and run pipeline. Once I click it, then it will create the pipeline completely and it will start running it. And the running UI, it will look similar to the Spark declarative pipeline UI. It is kind of part of that only. So currently, it is initializing our pipeline. And after it is initialization is done, then it has started our pipeline. So it is saying like it is creating some staging view, and then it is writing to our customers table. Now the execution, it is complete. So it has been completed successfully. So I will click here this icon to see the table. So this is our table, and let's check out some sample data here. So this is how the data looks. All our data has been loaded as it is from source to this particular table. So as we have loaded historical data, now let's try out some incremental data as well. And for that, I have created a separate script. So this script, it is going to insert two new records with customer ID 1001 and 1002. And the customer ID 1, that is what it is going to update. So this person with this customer ID, so his current entry, it is like it is in Mumbai and Maharashtra, and this is the annual income. And with this new entry, it is going to move from Mumbai to Bangalore, and the salary, it is going to increase. So we are going to promote this person. So I'm going to copy this entire script. Then we will go to our Postgres. There I will paste this script and simply run it. So now those records has been updated. And now we will run our ingestion pipeline again. So here is our pipeline. I'm going to simply start it again. So now as it is completed, we will go to our customers table and we will simply refresh this. So now we will see that the customer ID 1 is not visible here. It is because it is probably updated and here it will show only 100 records. So to confirm the data, we will have to query it in a notebook. So we will go to our project folder and here let me create a test notebook. And now let's try to query our table. So we will do SQL select star from this table. So here is our data. And if we see, so now it has 1002 record, two additional rows has been inserted and one has been updated. So if we sort by customer ID, for customer ID 1, we see that the city has been changed to Bangalore and the income has also been updated. So this row has been updated with the new data. And if we do the descending order, so these two IDs are the new IDs which we inserted. So these are also inserted into our table. So this is how incremental load it is made very simple using Lakeflow Connect. And here we did not have to write any additional code. We just selected the primary key and the watermark or timestamp column, and automatically it is able to take care of everything. So now revisiting our architecture. So we have now set up a Postgres SQL in Neon. We used the Lakeflow Connect. So the ingestion pipeline that we created, the technical term for Databricks in that is called as Lakeflow Connect. We used that, and then we have now brought in our customers table to the bronze layer. So now is the time to bring that table to silver layer. So let's go ahead and do that. So next, what we are going to do is we are going to load our customers table into silver layer, and that we will do using the Spark declarative pipeline only. So here, one option is that in this pipeline itself, our original streaming pipeline, we can add it, but we do not want to run that silver ingestion and that customers ingestion piece continuously when we run the streaming ingestion. That process will be running as a batch process. So that is why will not create that within this pipeline, and we will create a small separate pipeline for that. So I'm going to duplicate this tab, and in here I will go back to our old files. So this is the folder for FinGuard streaming that we are already using. So here we will create a new ETL pipeline, and this pipeline we are going to name it as uh, maybe FinGuard customers silver load, because this is what we will be doing here. So this is the name we have given. So looks like I already have a pipeline with this name. So in my case, I will put a 2 here. So this is our folder. So this folder also we will rename it customers silver load. And then this transformation folder, we will rename it as silver, like we follow the standards. And this is the default file which is created. So this one also we will rename it to customers silver. So this is where we will write the code for silver load of customers table. And for the code piece, we will copy our code from our previous transaction table. So this is the entire code. I will copy it from here, and then I will paste the same into the pipeline that we are building. So this time we won't need all these things because it is going to be simple silver load. So we will only need this DP and the functions as f. And the table name, it is going to be customers in silver layer. And then comment, it can be like passed and cleaned customers data, we can say. And in terms of data quality rule, we can say like valid customer ID. And then customer ID shall not be null. So I will simply press a tab. So transactions one, it is not required. And now we will write our main function. So the function name, it can be the same, customer silver. And this, it returns a data frame. And this data frame we have not yet imported. So let's import that. So it is suggesting it came automatically. And here we can write our code. So we can say like bronze df. So here we will read our bronze table. So spark dot read stream dot table, and the table name, it will be our FinGuard bronze and customers. And here one thing to notice is that even though this customers table we will be using as a batch load, but here we will be reading it as a streaming table. And this why we are doing, so that the incremental part and all can be taken care automatically by this streaming properties. So we will be running it in a batch mode like once a day or something, but to use those like incremental capabilities and this declarative pipelines, here we will be reading it kind of a streaming table. And if you notice the customers table that was created automatically, so the type of that table also is streaming table, even though we loaded it in a batch mode. So that is how things work in Databricks. So now our data frame is ready. And then like now we will do some very basic transformation. So we will call it as transform df. And then we will select the required columns, or like we will need all the columns. So then we will write the select statement here. And in the select, we will be writing multiple columns. So the first one, obviously, it is customer ID. So we will say f dot column, and then we need to specify customer ID. And here the hint that it is providing, so it doesn't know for sure that these are real columns. It is providing them just like whatever normal columns can be there in a customer table. So be careful, we will need to provide the actual column names only. So here what we will do is, because typing all the columns is very boring, so let's use Genie code here to help us out. So I'm copying this bronze table name. From this right side, I will open Genie code, and then I will start a new thread. This is where we start a new chat, and we will say like in this file, read all columns from this table. And here what we are going to do is we need all the columns as it is. Only two small changes we will be doing. So the first change, it will be about the date column. So the column that is here, account opening date, this is coming by default as a varchar, which is a kind of string. So this string we will convert it to a actual date. And then what we will do is we will add a new column also, that will be our silver ingestion timestamp, that will be current timestamp. So only these two changes we will need. So the same thing we will tell to this Genie code. So now here I will press Alt and then enter, so that it comes as a new line. So then we will say first, like we will say that account open date column shall be converted from string to date. And then we will say a new column, silver ingestion timestamp shall be added as a new column. And then third point, we will say like keep rest of all columns as it is. So this is the instruction we are giving. So based on this, it will do everything automatically. Otherwise, we would have to copy paste all the column names. So that we don't want to do. It is a very repetitive task. So now it is thinking what it needs to do, and it is reading the table structure of our bronze table, and then it will decide what to do. And now it is trying to make the changes to this file, the file which is currently open. And here we can see that it has made all the changes. So I will accept this. Let me accept this. And here let's have a quick look. So we see all these columns are being taken automatically as it is without any change. And while I'm checking, it is trying to do a dry run automatically. So I will stop it for now because I noticed one thing. So let me, uh, okay, it is still canceling, I think. I click this stop button. And the thing I noticed is this date conversion. So the rest of the columns it is taking as it is, and it is adding a new column as the current timestamp also. But this date, it seems like it is not converting it properly. It is just doing a like alias and then to date. Probably it has not checked the data in which format the data is there. So I will copy this, and then I will select this line here and then press this icon, or I can use this shortcut also that you see above, control I. So here I will tell that uh, this column is in format, this format, change it properly. So now it has explicitly specified how exactly it is going to convert. But when we use Genie from here, it is kind of a tricky. Like now, if we scroll, the accept button is gone again. There is no way to accept this change. So if I press escape, then like that it is undone. So I will ask it to do the same thing here. Like this column is in the format. I lost the format. Let me copy again. So this format, convert it properly. So now it has made the same change. So this time, like if I scroll, this accept button doesn't go away. So it is a good thing. And again, it is trying to do a dry run. Maybe we will let it do this time. So this change, I will accept it because now it is looking good. And here we can see that the dry run, it is successful. And whenever it does a dry run, it is like it will not load the actual data. It will just try to run it if everything looks good, there is no syntax error, those kind of things it does. So that confirms that coding wise there is no problem. And this dry run, if we want, we can also do it from here. If we click this button, we can also do a dry run. And now it is just trying to remove one space. So I will let it do it. It is again trying to do a dry run. So let me stop this time. So I will click this stop here. I will stop this also because we don't need this help anymore. So now we are going to go ahead and run this pipeline. So it is asking again for the default catalog and the schema. So we will select the same FinGuard, and then this time we can select silver or bronze. So this part it doesn't really matter because in our code we have mentioned the exact table name, full name, but we need to select some default one. That is how it works. So now it is actually trying to run the pipeline and then load the data. And looks like it failed this time. It is saying like cannot move tables across ArcLight catalog. So this error it is strange. Sometimes I get it. So let's see if this diagnose error it is able to fix it, or we will find some workaround. So it is trying to do some things, like it is trying to suggest to remove this catalog and schema name, which it did not work, and it is trying to try out different things. For now, I will reject this change, and then it is suggesting some options here and there. So I will stop it because this error it is strange. Previously also I encountered one time. If you have not encountered, that is totally fine, but if you have encountered this, so directly here we cannot fix this one. I tried previously also. So I what I will do is I will copy this entire code, and we will just create a new pipeline. That is what we will give it a try. So I will go to this all files, and this is our existing folder name. So here we will create a new ETL pipeline. So we will go ahead and create a new ETL pipeline here, and let me close this right side. So for now, we will not rename anything. We will keep everything as it is. Simply let me paste our code here and let's give it a try. Let's directly run this pipeline. And it is asking for a workspace and a schema here. So again, let's select our FinGuard. And this time, let's give it a try for branch because we are reading the data from branch. So now the pipeline has been started. It is waiting for the resources, and it has set up the tables, and now it has started the ingestion process. So like I was telling, that error, it is very strange. Probably you won't get it, but if you get it, you simply create a new pipeline and just paste your code. That is a workaround that I have found. So the ingestion, it is complete now, and as you noticed, the only change was that this time we selected bronze. So let's check if that is really a fix. Let me open our old pipeline from here once, and let's change this one to bronze. And now let's give it a try just to confirm if that is the real solution. So this time also it failed. So like I was doubting, this is some internal error in Databricks. Maybe they will fix it later on, or it could be in free edition. Maybe in actual Databricks I have not seen this. But anyway, it doesn't matter much to us. So what it means is that our code is working fine. It is just that uh, we just created a clone of the pipeline, and there it worked fine. So now we know, like, this is the pipeline that is working, and this is the folder where it did not work. So this one we will move it to trash, and this one we will rename it. So now let's give it proper naming. So let me open it again. So now it will become our fine FinGuard customers silver ingestion, and then 2, because I have some other pipeline with that name. And this folder also, let me give it the same name. So I will go here, I will rename this root folder, and it is done. And this piece also, let's rename it. This renaming is not that important, but just to maintain the standards, let's do that. So this one also we will rename it to customers silver. So now our pipeline is finally ready, and we had already run it. The data was loaded properly. So let's check out the data now. It is open. Let's check out some sample data. And here we can see the sample data. So if we look at the account open date, it is now a proper date column. And then rest of the things looks good. We have our silver ingestion timestamp as well. So now this table, it is there in silver layer and ready to be used. So if we come back to our architecture, so our table is there in silver layer. So now we are going to join this customers table with the transaction data that was coming from Kafka. So this Kafka transaction data is streaming data. Our customers table, it is the static table. It is not streaming. So we will join this. That is why we call it a stream static join. And then we will build a gold layer with the fraud detection, and then send real time email alerts. So let's work on that piece. So now I'm back in our streaming pipeline. So the gold layer, we will create it in the streaming part because it will be streaming data, not the static data. So for that, we will create a new folder first with the name gold. And then inside there, we will create a file. And this file we are going to name it high value transactions alert, because it will be used to send alert for the transactions where the value is higher than what is configured by customer. So for this we will start again with by copying the core stuff, and this time also we will not need lot of stuff, so we will only need these three. So let me remove these other things, and the table it will be created this time in the gold schema, and the table name we will keep it as same as our file name. So let me copy it from here only. So this will be our table name, and then here we will say that uh, we can say alert details where transaction has been performed with value higher than what is configured by customer. So with this is our target table. And now we will define our function. We will give it the same name, and this function it will return a data frame. So here we will start by reading our tables. So first we will read our transactions table. So that will be spark dot read stream dot table. So it is giving some suggestion. I will press tab. I only need this table for now. And then we will read our customers table. So that is our spark dot read. This time we don't need to read that customers table as streaming table. We need it to read it as a normal table. So that is why we are saying read dot table. And this piece it is actually very important, because uh, joining a streaming table and another streaming table, we need to add some additional details that we will see when we will join the transactions with the streaming data coming from files. But the joining a streaming data with a static data, that is relatively simpler. So using this keyword read and not read stream, that is very important. So this customer table it is our static table, and transactions table is our streaming table. So next thing we are going to do is join them. So we will say joined df equal to so it is doing some suggestion automatically. So I will press tab for now, and then I will remove these extra lines. So here it is saying that we can join the transactions and customers based on their customer ID. So this piece it is fine, but there is one more thing we need to add here. So by default, any join it is a inner join, and we can't do directly a inner join of a stream table and a static table, because streaming data it is streaming data, right? It is continuously coming. So we don't know, like after a few seconds the record may come which is there in customers table. That is why by default we never do a inner join with like on a streaming table. So there are ways to do it, but whenever we join a stream and static table, we directly use a left join. So why we do that? So that every record that is coming in transaction, that record is being done as a left join in customers. So for whatever transaction is coming, for every transaction, it will check if there is a record in customers or not, and vice versa. It doesn't have to check. That is why we use left join here. And then we will apply a filter to identify if it is like more than the limit. So for that we will say dot filter, and then we will mention that it is f dot column to mention the column name. So the column for amount it is amount, and then it is greater than f dot column, the column for transaction limit it is the transaction limit. So this column, it is there in the transactions table, and this column, it is there in our customers table. So that is how is combination now it is able to figure out that the transactions where the amount is more than what is currently configured by customer, so it becomes a fraud. And this fraud, it is detected by this join, and then it will be detected in real time, and then this fraud, it will be marked and stored into our gold table. So to store this data into gold table, we need to specify the columns that we need there in our gold table. And in the select, we will have multiple columns. So we will type it inside these brackets. So the first column we want to create is a alert type. So for that, what we will do is, so we will concat two things. So for that, we have a function concat ws, and in here we will concat like a dash, and there what we want to concat is like f dot literal, it means like whatever we specify, that same string uh, will be done there. So now it is saying that we can add transaction id and generate an alert id. So I will press tab here and delete this piece for now. So now what it will do is, it will, like, wherever we see this lit literal, it means this alert, this is a keyword that will be taken as it is. So it will be alert dash the transaction id, and the name of that column alert dash transaction id will be alert id. So this will become our alert id now. And then we also need to mention a column for alert type. So we will say f dot literal, and then we will say like high value transaction. So it is suggesting automatically. So I will press tab, otherwise we can type it. So there will be a column alert type which will always say high value transaction. It is for future use if we want to add more alert types into the same table. And then the next thing that we want is alert timestamp. So we will say like f dot current timestamp, and it is saying it can be there as a alert timestamp. So current timestamp, it will be added as a alert timestamp. And after that, we will bring in our ID columns. And for that, we will not use this F. We will simply say like transactions dot transaction ID. And then we also want the customer ID. So we will say transactions dot customer ID. And this, why we are mentioning this dot? So because for example customer id is there on both the tables, so it shall take it from transaction, and it will not throw an error that it is ambiguous or something. And next what we want is the email id. So customers table that has a column email, like I showed you previously, that we want it as an alias saying like customer email. So it is more like meaningful. That means like it is the email id, and this email id, it belongs to a customer. And then I will press a tab here, and transaction amount I need it here. But before that, I need the name of the customer as well. So for that, the customer table, it contains the name is first name and last name. So we are concatenating them and putting a space in between them. That will be called as customer name. And then we have transaction amount, so we need the transaction limit as well, that is there in our customers table. So transaction limit, it has been selected. The alias here, even if we delete it, it doesn't matter because the name is same only. And after the transaction limit, we need the transaction currency. So transactions dot currency, and then we need columns like transactions dot merchant name, so that we can know where it has been transaction has been performed. And then we have a merchant category as well, so that also we will brought in here. And then we will need some other columns, so let me just copy paste this so that this transactions part I don't have to type manually. And looks like intentionally I hit some run shortcut, so it is throwing that error. For now we will ignore it. So the next column, it will be transaction type, then it will be payment channel, then it will be city, then country, and then we have a column like whether it is international, so that is also very important. And then we will need two more columns. So one will be transaction timestamp and another one it will be status. So these are all the columns that we will keep into our gold table so that we can use them while sending alerts. So let me delete this extra space. And here I noticed that we had a transaction date. So we don't need a date because we have a timestamp. So I'm going to delete that piece. And then all these pieces, whatever is in the joined df, let me put this into a bracket so that it knows like these are the next lines and everything. And then this is what we are going to return and write into our gold table. So we will say return this one. So now this code it is ready. Let's give it a try and let's see what all errors we are going to get. So here is our first error that we got. It looks like there is some syntax related problem. So if I expand this, if I click jump to the code, so for this return statement, it is saying it is a syntax problem. So maybe the indentation, it is not proper probably. So what we will do is simply we will click on this edit button here. It will open this right side and we will say like fix the indentation problem of this file, because we typed this code manually. So some of the pieces are not aligned properly. In Python, it is mandatory. So let Genie fix that for us. So it has made the changes for us. So we are going to accept it. And now let's give it another try. So let's run our pipeline again. So this time the execution has started and it is running. Let me close the right side. Let me bring this into picture. So now we can see the bronze transactions is completed. There is no new data. Silver also completed, and high value transaction alert, the one gold table we created just now, that is also completed, but output records is 0. And why is that? Because currently there is no fraud data in our uh, stream that is coming. So that is why there is no data. And why is that? Because when we were pushing the streaming data in Kafka, we did not push any fraud related or any corrupted data. So let's do that first. So now I'm back in the VS Code, our producer part. And if I press up, so far as you know, we were running this Python normal.py. It is sending the normal transaction data, not any fraud related data. So to control the fraud related data, I have created a separate file that is fraud transaction. So that is the one we are going to run now. So here what we will do is we will mention like for FR, and it is saying fraud card, but not the fraud card. We need to run the fraud transaction. Fraud card, it has a different purpose. We may or may not need later on. We will see that part. But for now, we want to send some fraud transaction. So now if I press enter, so it has sent that fraud transaction. And the way I have designed this file is that it will send only one record so that we don't end up detecting so many frauds and then sending so many emails. So for now, it will just send one fraud data and then it will exit. That is how it will work. So now we have one fraud transaction to work with. That is good enough. So we will go back to our pipeline and simply run our pipeline. So this time, hopefully, we will get our first fraud. Let's see. So the bronze table, it has detected the new record and it has loaded it from Kafka. Silver also, it has been loaded successfully. And yes, in our fraud or alert table, we have got our first record now. So let's check out this record. I will click on this view in catalog button. So here is our table. Let's check out that sample or one record that has been created here. So here is our record. This is the alert ID that we created, alert dash the transaction ID, alert type, the timestamp, transaction ID, customer email. The email part, like I was talking earlier, this is very important. Using this ID, we will send the email. This is the name of the customer, the amount, the limit. As we can see, this is the limit set by customer. This is the transaction amount. That is why it has been considered as a fraud. And then there is this additional information that is also useful about this fraud. So now that this fraud has been detected and our gold layer table, streaming table will get it in real time, the next step is to send the alert email in real time. So now let's work on that piece. And for sending any custom email, we have like different options that we can use. We can use any of the SMTP services that are available. And for this project, we are going to use the Gmail one because it is very easy to set up. I already have a Gmail account. So for that, what we need to do is we need to simply say like Gmail SMTP API key. So we will need a API key that we are going to use. So this is what we will search. And here, I don't see that link. I think in Gmail it is called as app key in terms of Google. That's a different terminology. And yes, this is the URL. So it is like myaccount.google.com, then app password. So this is called as app password, not like a API key. It is kind of same thing, but this is Google terminology. So if I click this, then we need to select our Google account, which we want to use for sending the email. So I have selected my account. Now it is verifying. I will uh, cancel it or let me see if it works. Yes, it is working. So now I am on my app passwords screen. So this is where we are going to create a new app password. So here we need to give any name. Maybe we can give it the same name, FinGuard project, and then click on create. So this is our API key or app password that has been created. So I'm going to copy it and you shall create your own because this one I'm going to delete before I upload this video. So don't try this one. So let me save it to a notepad first. This I have saved here and I will click on done. So now this is ready. So first of all, before sending the actual email, we will first confirm if the app password that we have created, is it really working or not? And we will put it in our in our secret scope, not the key vault. So let's confirm that. For that, we can use this test notebook that we had created, or we can create a new notebook as well. So in this view, it doesn't seem to be allowing us. So simply, I will select this drop down and click on workspace because this is the pipeline view. So normally there we can work on the stuff related to these Spark declarative pipelines. So now I am back and let me find my project. This is my project and this is our notebook. So here, let me bring in some code related to email testing first. So this code I have prepared it previously. We don't need to type it completely because it is a test code that we are going to use. So this notebook I have included in the GitHub link that I have that it is there. You can use this same code. So here simply what we are doing is this is a body that we are preparing. It is a HTML body. So The format is HTML. We don't need to worry about it. It is just sending a test email from Databricks like that. It is saying. Then this is the subject of the email that we have hard coded here. And this is where we are getting the API key from the secret scope. So this is the name of that key. So far we have not stored that, so it will not work. So simply what we will do is, first maybe let me run this cell so that this piece is ready. And for this API key, for now we will provide the hard coded value, and later on we will put it in the secret scope. So I have provided this value here. And now this one, this is another piece you need to be careful. So this is my email ID, so using which I created the API key. So here you need to replace with your email ID, then only it will work. And this is the Gmail API key, this same one that we just pasted here. And this is to email, where we want to send the email. So this can be the same email ID or a different one. It is simply the ID where we want to send the email. And now I will run it. So it says email sent successfully. So let's confirm if we have received the email. So if I check my email, this is the email that I have received. This is the from email ID. This is the to email ID. And this is the test email. So if we have received this email, what it means is that our API key is working fine, and this sending of email as a testing, it is working fine. So we can use this functionality now. So now, instead of like again providing this code to our streaming pipeline, I'm going to copy this code as well. But before doing that, we will put this API key in secret scope as well, so that we follow the best practice. So I will copy it from here, and let's go to the setup secret scope. And then if we go below, so this is the last piece that earlier I was talking about. So it will be in the last cell. So this is the name of the key, and this is the secret value. So I am going to replace it with the new one that I just created. So now let's store it. Uh, let's see if it is running, or I need to run above cells. Probably I will need to. Yes, secret scope name is not defined. So this is the secret scope name that we have. Now let me run it. So now it is saying Databricks instance. So yes, here it is. So let me run this cell. Then this one is about creating the scope. So probably this time it will work. Yes, now it says like this has been created successfully. So now to confirm if this is working through secret scope, so I'm going to delete this cell that is has hard coded value, and I'm going to run this cell. So now it has read this API key from this secret scope, and let's give it another try by sending the same email again. And it says it is successful. So the same email has been sent again, and this confirms that this API key from the secret scope is working fine. Now to integrate this piece, I'm going to copy this code. This one cell of the code is enough. So I have copied it. Why? Because we are going to use Genie code here to integrate this functionality into our pipeline. So this is our streaming pipeline. So I will open it in the pipeline editor now. And with this, we are back in our pipeline. So here, now what we are going to do is we will use Genie code, and we will need to give it instruction. So let's give that. So what we will provide there is, probably let's type it in a notepad so that it is easier to understand, and then we can paste it there. So because I have copied the code here, so let me first paste that code so that I don't lose it. And then we will say that this is the table that contains our alerts. Okay, so we will say that the table, this one, created by, this table has been created by this file. So let's mention this also so that it can read the file if required. You will say contains the fraud related information where transaction has been performed with higher value than provided by customer. And then what we will say is that, like, this table contains information about transaction and other columns along with an email column. So we will mention that I want to send email to this ID in real time by reading data from the table in real time or is streaming. And then we will say that for sending the email, I want to use the below sample code. So integrate this code, and then we have our code. So what it will do is we are giving it the requirement what we want to do, and we are also giving it the sample code saying that this is the example or sample code that we want to use to send the email. So now let me copy this entire thing. Let's go back there and let's ask Genie code to do it. So now it is thinking. Let's see how much it is able to do. So it has prepared some thoughts. It is currently reading the pipeline details. And now it is considering different things. And now it is creating a separate file, looks like, with the name notify. So looks like it has done its processing. So let's try to understand that. So here is the file it has created with the name email notifier. And first let's accept these changes so that it is easier to read. So how it is saying is that what it does, it reads the streaming data from this table. It processes each micro batch in real time as new alert arrive, and then it send the email to the customer. So here we can see it has created multiple functions here. So like we had dp.table, and here it is using like a different function like dp for each batch sync, and then we will find another function here at the below. So it is about append flow. So it has created two functions. So let me ask it to like simplify this so that we can understand it in little bit better way. And also what it is saying is that next steps it is saying add your SMTP code. So this code it has provided and it is asking us to add here, and this Gmail API key also it is reading from the session because we didn't provide the code for the secret scope. So we will provide that. And currently, first let me explain like what it is working and how we can make it simple. So the flow it starts from here. So it says append flow. So this is a standard function or decorator. What it will do is whatever stream it is reading from this function, it will send that stream to this target. So the stream here, this is our table. So it is going to read this table, streaming data, every record or couple of record is a micro batch that it will get. It will read from here and send to this target. So that is what is this append flow. So append means keep reading more data and keep sending to this sink. And where is this sink is that? Here is our sink. So the data or the micro batches will be coming from there to this function, and it will be in micro batches. It can be single record or a like a couple of records in one group also can come up. So that is where we have this for each batch sync function. So for each of the batch, let's say in one batch we go 2 3 alerts in a single batch. So then it will perform that operation. So automatically when the data will come there, it will it will be received as a data frame. and it will have a batch ID also. So that is internally automatically that will work. And for this batch, this data frame, so this is the email part, and then from that data frame, it is collecting all the data. Then each and every row it is processing here, and then it is sending the email by preparing the email body and everything. So first, let's ask it to like make some changes so that the code looks bit clean. So we are going to open our send email file again. Let's see. This time it is opening here, and we will tell that API key is available here. So here we will say point number 1, that take the API key from here. And second point, we will say I want to segregate the email sending part from for each batch. So create a new function for this. So it shall be able to do that automatically. So let's open that file. Let's wait for it to do those changes. And now what it is saying is it is creating the file, and it is saying it will create a placeholder for the SMTP code. So why it is doing this is it is a safety measurement from the Genie code side, because it don't want to call external APIs automatically. So for now, what I will do is I will stop it here, and I will say that I have tested SMTP and it is safe. You shall integrate complete code, so that it is confident that the code is fine to integrate. And now it is saying that user has confirmed. So now it will integrate that code completely. So now what is happening is it has provided the code, and it is saying that we shall manually copy paste the code, because due to this external API, its internal mechanism, it is not allowing it to replace the code. So I will copy the code from here, and then I will select everything and paste it. So here I don't know why it is showing red. So I will reject this piece here. And then again I will delete it and paste one more time. And now the code shall be complete. So let me close the right part. Let's understand the code one more time. Hopefully this time it will be simpler. So this is the same append flow. So it is reading our streaming data as a alert and sending to this target email notifier sync. And then yes, sync part, it is simple now. So this is our sync. And in the sync, it is receiving the data frame and the batch ID. This is the from email ID, which is hard coded, because using this email ID only we generated our app password. So from ID will be this only. The app password, it is getting it from the secret scope. So it is doing it through like a difficult way, I would say. This code looks strange to me. So what I will simply do is I probably it will work, but I will simply remove this. I have not seen this earlier. This way it works fine. Then it is collecting all the rows from our data as rows, and then it is doing some processing row by row. So for each of the row in the from the table, whatever it is reading, it is first preparing a dictionary like the alert ID, customer name, transaction amount, all these things it is reading. And then it is uh, it is like preparing a subject. So this is the subject that we will get when we get the alert. And in the body it is calling a function like create alert email body, and it is passing this dictionary with all these details. That is where it has like now more modular code, so that we don't see a complex code for this email and get confused. That part we will go through, but first let's say here it is creating the body, and then it is sending the email. And it is sending the email by passing the email ID, subject, body, from, and the app password. So then it is saying how many emails it has sent successfully and how many has been failed, so that it can print it. So this is how it is sending the email. And to create the body part, it has created a separate function that we can see here. And send email also, it is a separate function. Earlier I thought it is a Gmail function, but for the body part it is receiving that dictionary, and from that dictionary it is reading all that different data and preparing a HTML well formatted message. So what exactly is this, we will see when we get the email. We don't need to understand each and everything here because this is HTML. If it looks good, we will be fine with it. If we want to make any changes, we can ask Genie and it will be able to make changes for us. So that is how it is preparing this email body. And then this send email function, which is the final function. So this is the function that is there. And here we are getting all those details. And this is where the email code that we had provided, it is integrating that. So it is calling the Gmail SMTP server and then finally sending our email. So that is how this code has been integrated. So overall, if we understand the flow, so it will read the streaming data. It will send the micro batches to another function. From those micro batches, it will read row by row data. It will prepare subject, body, and all, and then it will send the email. That is how the flow looks like. And for this piece, what we are going to do is, because it is not creating any table, it is sending an email. So for that purpose, we will create a separate folder for this one so that we manage it separately. So we will name it as alert. So let me create this folder and let me move this file inside that folder. So by default, it is not included as execution. So let me include this folder first, so that the file will get executed when we do that. So yes, now it is included and it will run this file when we run the pipeline. So with this, our code is ready. So let's try to run it and let's confirm if it is working fine. The expectation is that this one record that it had written, that same record, it will call this file and send the email notification. So let me run it. The execution, it is complete now, and looks like this email notifier sync, it worked well, and output record is 1, which means it has probably sent our email. And if we notice, so it has not received any new transaction. So other pieces, it was not able to process anything. Just the email part, it processed one record because this alert, it had it. And if we want to see the end-to-end flow, we can click on this pipeline graph. So here we can see all the steps. That first the table was loaded into bronze, then silver, then gold, and then the sync part, which is for each batch that sent the email. And it will look more beautiful when we will combine another stream to it, the file streaming later on. For now, let's confirm if the email has been received properly. So if I go to my email ID, so this email, probably it will not be coming to your inbox. It will go to spam because this Gmail, it will no, it will see it that coming from a personal email ID and saying about transaction fraud and all. So this one, it will probably go to spam. So check it out there if you are trying it out. So this is where we have received this email, and it says like we can report it as not spam, but for now I will leave it here so that it doesn't go to my main inbox. But this email has been generated saying that like we detected a transaction that exceeds your configuration limit. These are all the details. And then it is saying like if you authorize, then no problem, otherwise you shall report the authorities and all that immediately. So this is how the real-time alert looks like. We'll see it working end to end once we configure the other stream and then run everything end to end. So now if we revisit our architecture, we are done with this stream static join. We are done with the basic gold layer, although we will be building more into gold. Fraud detection one we have done. And then real-time alert also we are able to send now. So the main piece is pending now is like bringing in the streaming files for ingestion through autoloader. and do a stream join, and then detect another kind of fraud, and that also we will send real time alerts, and later on we will build a dashboard as well. And at the end we will do end to end orchestration where we will see everything flowing in real time end to end. So now let's get started with this streaming piece. But before that, I would say, like, let's use this point as another checkpoint, and you take some break, you understand it completely how it is working. You do some hands-on and see it working, understand properly. Then you will be ready to integrate the second stream. So once you are ready, then you can start again from here. So now let's start with the streaming files part. So to process streaming files, first thing we need is streaming files, right? We need some place where we will get streaming files. So first let's prepare that place. So in our sources, we already have this transactions folder or volume. It is a volume. Here we will create another volume. And this one, let's name it as fraud watch list. And why we are choosing this name is because here what we are assuming is that we will be getting some files which are being generated from a system which are also like monitoring the customer and card accounts. And whenever customer reports that the card shall be blocked, or if the card is blocked automatically due to some other fraud related activities, then what all cards and other information is being blocked, that information we are receiving through these files. And if any card, let's say if it is marked as that it is blocked or something, and if it is marked for fraud, for example, for this card we shall not be getting any transactions, right? So if still we are getting any transaction for that, that will be a fraud, and that is what we will be detecting through this stream. And here looks like I did a typo. Let me correct it first. So let me rename it. And here first we are going to create a folder where we will be receiving the file. So we will name it as source underscore data. So this is where we will be generating some files, and then uh, those files we will be processing in real time. And to generate these files, I have prepared a notebook that will generate the files automatically and keep sending to this location in real time. And that notebook I have kept in this folder that I will be uploading in GitHub. Inside this folder, there is a CSV file, and then this is the notebook that will generate that data. And in this notebook, there are two paths that we need to update or confirm if those are fine. One is the path of this CSV file. So it contains some CSV data that it will read one by one, line by line, and it will prepare JSON file and put it into that location. So we need to copy the full path of this file. So I have copied, and here we need to provide the full path. So this is the full path, and then this is the output path where it will be generating the files. So this path, it is the folder that we created just now. So from here I will copy this path and I will update this. So only these two paths we need to update, and then we will be good to go. So now I will run this notebook to generate those JSON files. And what it will do is it will send a single JSON file for a single record, and it will keep sending files with an interval of 5 seconds. So it will send a file, wait for 5 seconds, then send another file. That is how it will process the data. So currently we can see that one file it has written, it is waiting for 5 seconds. Then a second file it has written, it is waiting for 5 seconds. So that is how it will keep sending more and more files there. So for now, we will interrupt it so that we have some sample files that we will work upon. Later on, we will run it again when we will run our entire process end to end. So now if we go to the location that we had specified, and if we refresh there, so we will see that 4 files has been created. So if I open any of the file here, it contains a JSON data, and this data it contains a watch list ID, the watch type that it is monitoring card, and this is the entity ID, which is the card number. And for this one, risk level is high. The reason is that it has been marked as phishing card. So that way, like some other details are also being generated here. So this is the data that we will be ingesting now. So these are the this is our streaming source now, where new files keep coming. And to ingest this data, we are going to use autoloader. And to use the autoloader also, again, we have two options. Either we can write it in a normal notebook, or we can write it into our Spark declarative pipelines. So first we will understand in a notebook so that we can understand the functionality of autoloader first. Then we will integrate it into our SDP pipeline. So for that, I will copy this path, and then I will go to our project folder. We will go back. So this is where we will create that file. So we will create a new notebook here, and we will name it as 04 autoloader test. So first of all, we will create a source path variable here. That will be the path that we have copied just now. And after creating this variable, first let's confirm if it is showing the files here. So it is like dbutils.fs.ls. ls command, it shows the list of files available into this path. So as this is the variable, we don't need to provide the codes here. Let me run it. So here it is showing that those files are available here. So those four files are showing. So the path is correct. So now we will create a data frame. So we will say like input stream equals to, then we will do spark dot read stream, and then it is suggesting some options. So I will press a tab here, and here this option we do not need. First, let me explain these options. So, format cloud files, it means we are using autoloader. So, cloud files, it is the keyword that is used to specify that we are using autoloader. That is the standard name. And then we have more options which are specific to autoloader, like the option for format. So, cloud files dot format. Our file format is JSON. So, that is why we are specifying this. Then we need to provide a schema location. So at this location, it will store the current schema of the file so that in future it can compare and evolve the schema if required. So here we need to provide a path where it can store the schema location. So it will be similar to our checkpoint location. So what we will do is, so this is where the source data is coming. So here we will create a directory with the name schema, and then this we will use as schema location. And after that, we will provide another option to infer the data types of the file, so that we don't have to specify the schema of all the columns. So we will specify infer column types is true. And these are all the options that we will need. And then finally, dot load will be there. And in here, we need to specify the path that we are going to read. So this is how like we create a stream using autoloader. And here one thing to notice is that when we were doing a Kafka stream test, that time first we tried it with only read. We tried to read the batch data, and then we tried the stream part. But in autoloader, the normal read operation, it is currently not supported. So it only supports streaming way of ingestion. And this streaming way also, we can use it kind of a batch ingestion as well when we use the trigger type as available now. So it can work in both scenarios. So this will create our input streaming data frame. So it is ready now. Next, we will do some minor transformation. So let's say transformed df. So here what we will do is, we will take this data frame, And specific to autoloader or anything, whenever we read any file in Spark, like outside autoloader, outside streaming anywhere, then we get some additional file related properties also. Those we can read. So let's say in here select, what we will do is, so all the existing column we will select as it is. So we will say star, and then we will add any additional column. So f dot call, and then there is a specific keyword like underscore metadata. So it is coming automatically dot file path, and alias is file path. So this will add a new column file path which will store the complete path of the file. So this keyword it automatically get that data. So we have other things also like modify time, file name, whatever we want we can get it. And then also we will get the current timestamp as well. So this one we will call it as ingestion timestamp. So this one will be a comma here, and that's it. So this is the data frame that we are going to write. And as you may have guessed, this F is currently not available. So we will need to import it. So so it is giving it automatically. So we will import it. So this will be our transformed data frame. And now this one we will need to write it to a table. And for that, let's copy our code that we used in Kafka streaming because it will be almost the same only. So, yeah, this is the code that we had. Let me copy this. And if we go back here, so here, this is the transform df. So I will replace it, and it will write as a delta table. It will write in append mode. And then we need to provide a checkpoint location. So this location, we will create another one. So for fraud watch list, let's create a directory here, which will be called as checkpoint. And at this checkpoint location, it will keep track of the files that it has processed in the current run, so that in the next run it pick up it doesn't pick up those files again, and it only picks up the new files. So that is the checkpoint location we will update here. Trigger type, so we will use available now only, so that it will only run once and then exit. And to table, so this table name we will name it as uh, fraud watch list, then batch test. So this is the name we will provide. Now I'm running it. So it will read those files and write the data into this table. So now the execution it is complete. Let's check out the data in this table. So here is our data. All those 4 records has been read here. All the columns has been created properly. And this is the file path that I was talking about. So for each and every file, it is putting the complete path of the file using that underscore metadata dot file path. So this is how autoloader works. So writing part, it is exactly same. Reading part, we need to provide this cloud files and cloud file specific options to read the data as streaming using autoloader. So now as we understand this using a normal batch data or through this notebook, now let's use the same in the Spark declarative pipeline. So for that, we will open our same streaming pipeline. And here let's go to branch. So this one, what we will do is we will clone it so that some of the pieces will be same. So we are going to name it as prod watch list, then branch. So this way we are going to clone it. So in here we will not need everything. So we will remove these pieces. The table name we will create it as fraud watch list. And this one it will be like fraud watch list raw data ingested by autoloader. And this function also we can rename it to fraud watchlist branch. It will return a data frame, and all these things we do not need. So this streaming df, creating this, it is simple in case of autoloader. So we will simply copy it from the notebook that we created just now. So let me open that. So this is our streaming df now. So let me read it. So I have copied it. Now let's take it to the streaming df here. So I have replaced it now. And here the source path, it is also not available. So directly we will put this path there. So I will copy this and directly put this into this code. And one more thing, so this schema location also, now as we are using SDP pipeline, so it will be maintained automatically. So we don't need to specify this option. So this is one advantage that we get. Rest of the things will be same. So now we have our streaming df. And next what we need to do is, from this streaming df, we need to select the columns that we need. So in our case, now we have imported F. So this is another way to specify those. And this current timestamp, we will still keep it. So let me put the other columns that we are going to keep here. So let me simply copy paste it so that we can paste those columns. So the columns that we have now are like watch list ID, and then we also do not need casting here because the columns are already string. So let me paste this one. And then we have watch list type. And then we had entity ID, entity type. Sorry, entity type is not there. So let me remove this. Or I will just use another column, that is risk level. Then we have action. And then we have reason code, reason description. After that, we need status. And then we need effective from. And after that, we need reported by, reported source. After that, we have country and then city. And then we have something special, which is rescue data. This one I forgot to talk about. We will talk about it. So this column, what it is a column added automatically by autoloader. So the table which was created just now using autoloader. So this is the column like underscore rescued underscore data. So this column, it is created by autoloader where it will store any data that is corrupted. So in JSON, if we get any corrupted data which doesn't fit correctly into these columns, so that data it will put into rescued data. So this functionality is provided automatically by autoloader. So it is rescued data. And now we are left with only one, which is our file path. So that one was underscore metadata dot file path. And this one we will give it a alias as well. We will name it as source file so that we know it is a source file path. And then we will keep our current timestamp as ingestion timestamp also. And you may ask, like, why did we provide this everything in a specific, like by putting it one by one? So the reason for that is, so even though in our file we had things like watchlist ID type in this order, but it read this entire JSON and the order of these columns is not guaranteed. So when this table was created, So if you look at it, it has like action, city, country. So the column order is different. That is why we specified each and every column so that we get these columns in the same order. So now this is our parsed streaming df that we are returning, and this will be written into our bronze table. So with this, our bronze, this pipeline, it is ready now. So let's run it and let's see this table created. So now I will go ahead and run this pipeline. And while this is running, so the other thing to notice is that here also for writing part, we did not have to specify any checkpoint location because it is taken care automatically by the SDP pipelines. So it has been failed saying like no such field is there file path. So we forgot to put a underscore there. Let me put it now. So here we need to provide it. Now let me run again. Now we have a second error which says like watchlist type is not there. So this is actually watch type. It was a typo. Let me correct it. And this time I missed the spelling effective from. So let me correct it. And the thing is, it will not tell each and every error in one go. So we have to fix them one by one. And this reported source also looks like I made a spelling mistake. So sorry for all these typos. Let me correct them. So now we can see it has written those 4 records, and it is currently running in the continuous mode because after last time we did not change it to trigger type. So I will stop it manually for now, and then I will change the trigger type to triggered so that for the development purpose we can run it only once. So now our table it is ready. Let's check out our bronze table for fraud watch list. So here is our table. Let's check out our sample data. So after working for a few minutes, looks like the compute is currently not available. It is very busy. So this is serverless type. So what I will do is I will try to copy it in a notebook where the uh, serverless, like which is not SQL compute, the normal serverless compute is used. So there, let's see if it is working fine. So we will try to query this table. And yes, here it is working. So if you also encounter this kind of problem, you can try the normal serverless compute. So here it is, the data is coming properly. We can see that the watchlist ID, risk level, action. So action is in uppercase. These are in lower cases. So we will convert them to upper cases when we go to silver layer. And then this effective from column, currently it is a string. So we will convert it to timestamp when we go there. Other columns, those are created properly. So now is the time to load this streaming table into silver layer. For creating the silver notebook or silver file for fraud watch list, we will simply clone its bronze because there are only very few things we will need to do there. So we will clone it in the silver part. So this is the clone file, and we will name it as fraud watchlist silver. And here the name we will change to silver schema so that it will create in schema silver part. Here we will say like we can say cleaned fraud watch list. That is the only thing we will give here. And then this one also we will rename it to silver. And for this streaming df, so we don't need to like provide all these things because here we will be reading a table. So we will simply provide an option dot table, and we will read our bronze table here. So it is providing as a suggestion as well. So this is our streaming df now, or we can name it as bronze df. And now in this bronze df we will say like cleaned df or standardized df. We can give it any name, it doesn't matter. And then we will make some standardizations like this watch list. So we need it in the uppercase. So we will change it to uppercase. And apart from this watch list ID, this entity ID, risk level, and action. These also we will change them to uppercase. So it is done. And then current timestamp, we will keep it as silver ingestion timestamp. And then rescue data, we normally don't bring it into silver layer because its role it is until bronze for debugging and everything. And then the existing ingestion timestamp column. So that one we will name it as bronze ingestion timestamp. So it is done. And now we need to make one final change that is about the timestamp column. So if we look into the file that we are ingesting, so this effective from column, it is coming in this format. So I will copy this. So this format, currently it is being ingested as a string only. We will need to convert it to the actual timestamp column. So this one, we will select it and then I will press Ctrl I. We will say convert this string from this form to the actual timestamp. And it has done it for us. So I will accept this change. So this is also casted properly. And now this cleaned df, this is the one we want to return and write it into our silver table. So now let me go ahead and run our pipeline again. So now it failed, saying that there is some invalid character. So let us ask Genie to fix this error. So we will simply click diagnose error. It will check where is the problem and it will fix it. So now it has updated these things. It is trying to do a dry run. So I will accept these changes. And here the fix it has done is it has put alias. So looks like this upper function, it works only with alias. And now I will stop it. And the next error that we have is about this metadata file path. So now because this column file path itself, it was there in the bronze. So underscore metadata will not be available. So the actual column name will work now. So this time it is working fine. And here we can see that in our silver table, it has written 4 records now. So now let's check out these 4 records. For that, we will go to a notebook and then just try to query it. So we will say FinGuard dot silver and then dot fraud watch list. So here we can see that those 4 records has been written properly. The effective from column also it has been converted to a proper timestamp column, and also the watch list ID, the watch type, risk and action. These columns also has been changed to uppercase now, and rest everything also looks fine. So with this, our fraud watch list table, this is ready in the silver layer. And if we look at the pipeline graph now, so we can see fraud watch list is being ingested parallelly and then transactions are being ingested parallelly. So now is a good time to join both the streams and find some more fraud detection scenario and then send email. So if we revisit our architecture, so we can now say that 2 streams are now being ingested in bronze and silver. And the next part, we will work on this stream join. This is going to be interesting. And before we actually do it, there are some two, three concepts that we need to understand first, so that once we are clear with those concepts, then when we do the implementation, it will be clear. So let's understand those concepts first. So first of all, let's understand the concept of stateless versus stateful stream processing. So far, whatever we did with the transactions only data, so there we did a stateless stream processing. There, what it means is that no memory of past events is required and each event is processed independently. So whenever we received the transactions event from Kafka, so each and every event it was processed independently and there was no dependency on other events. So as and when we were getting each event, we were processing them. So there was no interdependency among events. So that is why it is called as stateless stream processing. On the other hand, we have second type, which is stateful stream processing. So this it need to maintain some state or memory of past events to process the current event. So how it works is new events keep coming. We do some processing and we keep some memory for some time. How much time and all we can control it, we will see. But we have some memory. So new events they keep coming. We check something in the memory and then we process them. And then we write some output. So we need some kind of state for this. And that is why these are called as stateful stream processing. And if we take some example, so stateless, it can be simple filter event like we used wherever we filtered out the transaction amount greater than some value. So if we have some fixed value, that can be a simple filter event. If we have a simple map like one to one record transformation we want to do, like casting, conversion, something like that, or if we want to enrich it with some static data. So in our case, we combined our transaction with the customer static data. So that kind of processing also comes into stateless. Or if we want to do some simple routing, like based on some value, if we want to route between different tables or various routes. So for that, we don't want any memory. So that is why these examples come under stateless. Wherein stateful, there are different type of example. Like if we want to do some rolling window aggregation, let's say if we want to know every 5 minutes how many transactions are coming. So for that, for 5 minutes, we need to keep counting and keep things in memory. So that is why it is there. And if we want to do like per user session, if we want to capture some detail for some kind of processing, for running total counts, like how many records or how many events are coming in total, so for that thing, or for advanced fraud detection also, that we will do now, there also we will need a stateful kind of processing. So simply putting, on stateless there is no state, on stateful we maintain a state. In stateless, the latency it is less because as soon as we are getting the data, we are processing each and every event. In a stateful, there can be some latency, and that will depend on how much memory we are keeping. This one we will see next, how do we control it. On stateless, the resource usage is less because we don't need memory and single record processing can be there. Here, resource usage is more because we need to process multiple set of records together. This is easier to scale and manage, wherein stateful it is for powerful use cases. So it is slightly difficult to manage, but it is worth it because that is the use case that we need. So this is the core definition of stateless and stateful. And to maintain some of the things in stateful, like how do we handle late arriving data or how much memory, up to how much time we want to keep the memory, all these things we need to control. So to control all these things, we need something called as watermarking. So watermarking, this is a kind of concept and a functionality in structured streaming. So this is what is a watermark? It is a threshold on the event time. So here what we do is we define a timing window, like how much late data we can consider when it is arriving late. So we put some threshold. So whatever data is earlier than that threshold, that will be considered final. And whatever data that we are getting after that threshold limit, So that data we will not use. So if we understand it from an example, so let's say we are getting some data and we have configured our watermark as 10 minutes. So how it works is, so let's say we are getting these different events on a particular time, and the latest event that we have, that is from 12:30. So if our watermark is 10 minutes, then the current watermark value or the latest allowed limit of the data, that will be 10 minutes before the latest data point. So for this example, it will be 12:20. So whatever data is earlier than 12:20, that data will be ignored. It will not be considered. And if the data is within these 10 minutes, that will be considered for processing. So that is how this watermarking it works. And how do we define it? So we define it using this with watermark. We give a column name, the column that we are going to use for watermarking, then the value, whether it is minutes, seconds, or hours. So most cases it is a few minutes, but it depends on the use case. But this is how we define it. And then there is one important aspect of it that is sometimes misunderstood, that whenever we have defined this 10 minutes, so this 10-minute it is considered based on the latest value received of this column. So it is not like 10 minutes before the current time. It is before the latest value of this column. That is how the watermarking works. And these are some key points that this is used to handle late arriving data. So here we define a threshold, like up to 10 minutes of late data we will allow. Earlier than that, like or older than that, we will not allow. And with this we get a kind of bounded state. So we get a fixed window that we will process, and that this much of data we will keep in memory. And with this way we get some accurate results, because otherwise there is no limit in the streaming data how much data we can process. So now in our use case, we are going to join to streaming data. So to join to streaming data, defining the watermarks is important, so that whatever data is falling within that watermark values or that window of that watermark, that data will be considered for joining. So continuously the data will be coming. Whatever data is falling within that window, that will be joining, and then we will be getting the results. And if some data arrives later than that window, or some like the value is late, value is like less than the watermark, and it is received after the processing time, then it will be ignored. That is how the join will actually work. So now let's go ahead and implement this scenario. So now to implement that scenario, we are back in our pipeline, and to join both the streams, we will build another goal table, which will be doing like join of the streams and then preparing another kind of alert. That alert we will name it as fraud card alerts. So what we are assuming is that whatever data we are getting through this watch list, so all those cards has been marked as inactive or for related to fraud. So whatever transactions we will be getting for those cards, so those we will be considering as fraud, and we will be sending an alert. So let's go ahead and join both the streams. And to do that, we will copy this ready to use code here, the one we prepared earlier. So let me copy this much of the code. And then we will prepare another file inside this gold one. And this one we will name it as fraud card alert. So let me paste the code here. So this will be same. This one we need to rename it. And this function name also we can name the same. And here, as you can see, one stream we are already creating for transactions and customers. So this also we will be using it later on, so that we can bring in the email ID to send the email. But this one we will be using it later on. First, we will join the second stream here. So let's bring in the fraud watch list. So it will be similar like spark dot read stream dot table, and it will be FinGuard dot silver dot fraud watchlist. So now both the streams are ready. Next, what we are going to do is we are going to add the watermarks to these so that we can perform the join. And to add the watermark, we will name those as like transactions with watermark. And then we will say, oh, it is providing some automatic suggestion. So I will press tab here. So for customers, we don't need a watermark. And this is the syntax of watermark, like I was talking earlier. So this is the transaction column that it will be using. And currently it is saying 1 hours, but we don't need that much of a big window. We will simply keep it 5 minutes. And then for fraud also, like the column that is there, so we will be using the effective from column. And then the watermark also, we will keep it 5 minutes. In practical scenarios, it can be like multiple hours also, because the transaction that will be happening and when it will be marked for fraud, so we want more overlapping for that. Or in real scenarios, it can be even in days. That is also practical, but in our case we will keep it 5 minutes, so that within 5 minutes whatever fraud card we are getting and whatever transaction is happening for that card, that will be considered as fraud. So now we have like provided a boundary to the streaming data that this watermark 5 minutes. So within 5 minutes it will keep doing joining, and whatever data is matching, that it will keep providing in our output table. And the data that will arrive later than 5 minutes, that will be ignored automatically. So now let's go ahead and detect this as a fraud. So we will say that fraud detected equals to, we will be doing multiple things here. So first of all, obviously it will be a join. So it is providing this as a suggestion. So we will take our transactions with watermark dot join, and in this join, first we will pass the fraud watch list with watermark, and then we need to pass the joining column. So we will say that from this transaction part, we will be taking the card number, and it shall be equal to, in the watch list, the column name, it is entity ID. So when both are matching, that means it is a fraud. And the join type here, this one we have to take it as inner join. Why? Because once the entry is available on both sides, then only it is a fraud. Otherwise, it is not a fraud. And this inner, it will work because of our watermark, so that it will detect everything within the 5 minutes. So now we have detected our fraud. The next thing we need is the email ID so that we can send the email. So we will now join our customer table. And this one, as we know, so it is not a streaming table, it is kind of a lookup table. So this one we will join customers. And this joining condition we already know. It is like customer ID on both sides. So we will take this one dot customer ID equals. Then we will say customers dot customer ID. And then the join type. So join type here, this one it will be left join, because stream directly like we shall not do inner join here, because like it is a lookup table, and whenever email ID is available, that we shall join. And now our tables are ready, tables or the data frame. Next we need to select the columns or the details, whatever we need to do here. So this time let me pause it and type everything first. So here I have typed it. So similar to our transaction with higher value, we are generating a alert ID. This time we are saying it is a like fraud dash transaction ID dash watchlist ID. And then alert type, we are saying it is a like fraud watchlist match. And alert timestamp, we are taking as the current timestamp. Then we are taking the columns from like transaction ID, customer ID, and customer email also we are taking that we will use to send the email. Customer first name and last name we are preparing. And then multiple columns we are taking from the transactions. So all these columns are direct selection. City and all these we are putting an alias to understand these better. And then from the watchlist side also, we are selecting watchlist ID, type, all these columns. And effective from, we are renaming this column like watchlist is effective from. And then these are as it is. And then city and country also, we are marking that this is watchlist city and country. So that it is not like misunderstood with the customer, city, country, etc. So with this, all the columns that we want, we have selected that. And now our table will be created automatically. So now this table, it will contain the alert data like we had for transaction alert. And the next thing we need is the actual alert. So for that, we will need to create this kind of sync. And this time we will not type everything. We will use Genie code because it will be a similar activity. So let me open Genie code here and let's start a new thread. And the prompt that we need to provide here, first let's prepare that prompt separately so that we can understand, and then we will paste it here. So how we will provide it, we will say that we have prepared this file which reads this table and send an email notification. Similarly, prepare for this one. So we will copy this name. We will say that there are high value transaction alerts logged in the table which are fraud, and an email is sent using the file. Let me copy the other file name. This file name. So we will say this is working fine. I want you to implement, or we can say like create a new alert file that read the fraud data from. Then we will give our table name. So the table name will be this one. This table, and send email notification. And this table, it is not yet created. So let's give it the file name also so that it can understand what all columns are there. So we will say this table prepared by this file. So this is the prompt that we are going to provide. Let's see how much it is able to write for us. So I have typed it. I will press enter. So it is currently understanding all the details. Now it will create a new file. So looks like it has created this file. So currently it seemed to be blank. It is updating the file. And now it has created the file, but it is not able to write the data. It is saying that similar safety alert because we are using the SMTP API call. So it has provided the code. So I will need to copy the code from here and then paste it. So now I have pasted the code, and let me close this right side. Let's have a look at the code. So the code is similar only. This is our send email function. This is the function that is creating the body of the email with so many details. And then there are these other functions. So this one, it is reading our fraud card alert table as a streaming table, and it will keep appending the data using append flow to this target sink. And what is this sink? It is this one. So here it will send that data as a data frame and batch ID. It is reading all the API key and preparing the app password. Then the data that has been read as a data frame, so it is collecting all the rows. Then it is going row by row here. And after that, it is preparing the body of the email using the above function. And then it is sending the email using above function. So structure wise, it is exactly same to the other file, and it will send the alert notification. So now this piece has been set up end to end. So now let's see it in action. So what I will do is I will change it to continuous mode so that we can start it and then send our data and see it in action. So I have changed it, and now it is starting our pipeline. And this pipeline, it seemed to be having an issue that comes up for a second and then goes away. This is happening due to continuous mode. So for debugging, for now, let me change it to triggered, and let me stop it manually. And then let's do our first run as a batch kind of run or one time run. So now we are getting the actual error. It is saying that transaction timestamp, it has the invalid type string, but it is expecting a timestamp. So probably we have created our transaction timestamp as string type. We can see here. So this one, it needs to be of timestamp type. So what we will do is here we will change it to timestamp type. So it has been changed. And now we will run again, but this time we will not do a run pipeline. Instead, we will do a full refresh. So whenever we are making some changes that can affect our historic data, so while development, so for that we need to do a full load so that it will recreate the tables. So this time we will do a full table refresh. So this time the error is that we are not returning anything. Probably it is saying it is returning none type. So let's jump to the code. And here we can see that this fraud that we had detected. So we did not put a return statement to this one. So let's put it. Now let's run it again. And this time code wise things looks good. So it has started the pipeline. So first it is running the bronze layer tables. So for fraud watch list in total we have 4 records only. It has written those. And same it has written to silver fraud list as well. And for transactions also it has read all the records again. And then it has written to silver layer as well. And then high value transaction alert, it has generated one record. And for that it will be sending the email as well. And for fraud watch list, it has detected 2 alerts. So we have 2 such records based on these 4 cards that were there. 2 transactions has been marked, and it has sent the email as well. And if we see my email ID, so these are the 3 emails that we have received. This is the similar high value transaction alert, the same email that we had got previously. And this is the new email for that fraud card related alert. And depending on the risk, it is saying whether it is high or low risk. And then it is providing all these very detailed all the details here. And we can see the formatting also, it looks really nice here. This is because of the detailed HTML code that Genie has generated for us. So if we are fine with this, then we are good. Otherwise, we can ask Genie to customize it as well, however we want to. So this is how our stream and stream to stream join is also working fine. And now if we go and check our pipeline graph, so this time it looks like more interesting. If I make it like bigger, so this is how it will look like. So both the streams are coming until silver layer. For high transaction, we are using only one and sending the email. For fraud card alert, we are joining the both and then sending the email alert. That is how it is working. And at each and every step, it is showing the number of records as well, how many records has been uh, generated at each and every stage, so that we get proper visibility. So now, as we have understood stream to stream join as well, the next thing we are going to understand is how can we do aggregations on streaming data. And aggregations, again, it will be a challenging piece, because let's say if we want to get number of transactions, so if we go ahead and do number of transactions, like count of transactions, so by default on streaming data, it will keep adding more transaction, and it is kind of continuous, right? So there is no limit when it will stop and give us the count, that this is the count. So there also we need to provide some boundary, how much data we want, or how much, after how much time we want to do the aggregation. And to provide that uh, time limit, we have some functionalities specific to streaming data, that is called a window. And we have mainly two types of window that we can use. So let's go ahead and understand those. So the two types that we have, those are tumbling window and sliding window. And this one we call it as bounding the unbounded stream, because using these we provide some boundary. So first let's understand the tumbling window. So this one, it is like a non-overlapping fixed size window. And what it means by that is, let's say here we are getting some events continuously, and we define a window of, let's say, 10 minutes. So 0 to 10 minute, it is one window. 10 to 20, it is window number 2. 20 to 30, it is third window. So these three are fixed size window which do not overlap with each other. And in this case, each event belongs to one window. So wherever the event is, it will belong to only one window. And results are produced when the window closes. So it will keep getting the data, keep getting the data. Whenever it will reach that 10-second, then it will provide the aggregation value, whatever is required. And the second type of window that we have is sliding window. So sliding window, as the name suggests, it keeps sliding. So in the similar case, if we have this data from 0 to 30 minutes, so here also window size is 10 minutes only, but we keep sliding this. So for example, 0 to 10 minute, it is one window. Then 5 to 15 minutes, this is our second window. So this window, it seems to be slided by 5 minutes. Then uh, 10 to 20 is another window, 15 to 25 is another window, then 20 to 30 window comes. So within the same time of 30 minutes, here we had these three windows, here we have five windows, because the same window, it keeps sliding. So here we can say that window has a size and a slide interval. So what it means is that we will need to provide two parameter whenever we configure it. One will be the size, one will be the interval. In case of tumbling, we will only provide the size. And here windows can overlap. And because these can overlap, so whatever event is there, that may belong to one window or two windows as well. So in a nutshell, we use tumbling window for simple non-overlapping aggregation. Let's say if we want count of transactions every 10 minutes, then we can use this kind of window. And let's say if we want more frequent up-to-date insight, let's say we want every 5 minutes, we want the number of transaction of last 10 minutes. Then we use this kind of window so that here it will give these 10 minutes. Here it will give these 10 minutes. Here it will give these 10 minutes. So these are more up to date, because every 5 minutes we are getting the data of last 10 minutes. We can do it like every 1 minute also, and window size of 5 or 10 minutes. So that is how we can customize it. So these are the two types of windows that we can use and do some aggregation. So let's now understand how practically we can do it. So to do that piece, we will again create another gold table. So for that, let me copy this piece of code from here, and then we will create a new file here. And this one, uh, we will name it as transaction count, we will count the number of transaction, and then we will say by minute. We will try to do it every minute. So here I think I forgot to put the dot, so it gave a warning. Let me type it again. And then here, let me paste the code that I had copied. And then let me copy this name. And then we will create a table with this name, and this function also, let's give it the name. And here, because we are counting the number of transactions, so this stream only we will be using. So now before we do the aggregation using window, here also we will need to specify a watermark so that we can tell it how much late data we are allowing it. So that it will wait for that much of time and then it will do the aggregation. So if we go back there, so this same watermark we will add here. So here also we are saying that we will allow the late data by 5 minutes. And now we have everything. So now we will do the actual aggregation. So what we will do is we will say transaction count equals to, we will take this watermark value and then do a group by first. So it is providing a suggestion here. And in the group by, this is where we need to specify our window. So the window that we are going to use is, it will be f.window. And then we will mention the timestamp column that we will use for preparing the window. And then similar way, we need to mention the size of the window. So this is how we will specify. And window size, this time we will keep it 1 minute only. So this will be our tumbling window. So every 1 minute, it will do the count of transactions. So far this is just the group by part. Now let's mention it what we want after doing the group by. So simply we want like f.count star. And this count star that it will do, we will name it as transaction count. And after doing the count, we want to select what data we want in the output table. So in the select also, there is something specific to the window. So when we say f.column, so the window that we are using, so we have window.start and window.end timestamps that we can take. So I will press tab here, and this window.start, this one I will name it as window underscore start as a column. And then window.end, that we will name it as window end. And after that, we will take our transaction count, and that's all. So in our target table, these will be the 3 column we will be creating. So we will see a window start time, end time, and the count of transactions within that window. And now this is ready. So this name may be confusing for this. So I will name this one as df because it is a data frame. And this is what we will return so that it doesn't fail this time. So this is what it will create this as a data frame. And then this data frame, it will be written into this particular table here. So now let's go ahead and give it a try. So I'm going to run the pipeline. And this time also it failed with some error saying like, oh, column object is not callable. So if we jump to the code, it is pointing something here. So let's diagnose the error and let's see what is the fix for this one. So now it has made the changes. So looks like it made it, okay, 3 places. So here we can see it was a minor issue. So just this bracket, it has to be right side the group by. So let me accept this. And now let's see what other change it has made. So it has also made some change in this alert email notifier. And here what it is trying to do is, earlier this app password and this secrets.get, it was inside this function. So for every batch, it was calling it again and again. Now it is putting it outside. So it will be optimized, and probably these warnings like not serializable, these also it will be gone, because I think it noticed that and then fixed it. So that is also good for us. So I will simply accept all the changes now. And then let's go ahead and run it. So this time the pipeline has been started. And now it is successfully complete. And this time this was the only new table. So it has written the 5 records for that were there in the last 1 minute and delayed by 5 minutes. That way it has prepared some data for 5 minutes. And rest of the thing, because we did not have any new data, so there is no new data coming in. So let's go ahead and check out this table. So this time we will copy it in a notebook directly. So we will do a select star from FinGuard.gold. Then this is the table we have prepared. So here we can see the data. So if I sort it by transaction start time, so here we can see that 654 to 655. This is one window where it got 61 transactions. Then 944 to 945, it got 18 transactions. And why we see this gap is because this video I have been recording this over different hours. I'm taking breaks and all. So whenever we send the data within 1 minute, that is what it is capturing. And here we can see a good window that 11, 16 to 17 was one window. Then 17 to 18 was the next window. So this is how for every minute we will keep getting data here. So this is our tumbling window, and this is the aggregated value for each of the tumbling window. So now as we understand the tumbling window aggregation completely, so next we will give it a try for the sliding window, and that one it is going to be very similar to this and very easy. So simply let's copy it. So we will clone this file and make that minor change. So this one we will, instead of simply saying count by minute, we will say count by minute, and then we will mention sliding window. And in here I put a dot. So let me remove this. So now this has been cloned. And here also let's create another table with the name sliding window. So this will be our target table. So here also we will be doing the exact same thing, but this time our window size, we will change it to 5 minutes. So let me change it to 5 minutes. Why I am changing? Because we need a sliding also. So sliding, we will keep it for 1 minute. So what it will do is every 1 minute, it will do the aggregation of last 5 minutes. So that is how it will work. For example, it like 400, it will get the data of last 5 minutes. At 401, it will get the data again for the last 5 minutes. So 4 minutes, those will keep overlapping again and again. And by 1 minute, it will keep sliding. So if we want to understand from this perspective, so this window, we have kept it as 5 minutes. And this sliding time, like how much it is going to jump to the next one, that one we have kept it as 1 minute. And that's all the change we want. So this is the only difference, only one additional parameter, and it becomes a sliding window. So now let me go ahead and run this pipeline again. And the execution has been started now. So while it is running, let's have a look at our pipeline graph now. So it looks more expanded now. And as we can see, from transactions, now we are doing multiple things. So the fraud card alert, the high value transaction alert, and also we are preparing two more streaming tables now with the two different type of window based aggregations. And here we can see that it has already written 21 records now, and then it has stopped. So now let's have a look at this newly table that has been created. So let me query this here itself. So this is the sliding window table. And here we have like lot more data for the same window that was for tumbling. So now we have more data, and there is a reason because it is a sliding window. So this is what we were talking about. So 50 to 55, 650 to 655, we have 61 records. Then 51 to 56, we have again this many records. 52 to 57, again we have this many record. So as we can see, it is sliding by 1 minute, and the window size, it is again 5 minutes every time. So that is how this sliding window works. So these are all the tables we wanted to create using this streaming pipeline. So now what we will do is, now let's have a look at the streaming data flow end to end in real time in all the layers. So for that, what we will do is we will start our pipeline in continuous mode, and then we will start our streams as well. So it has been started here. So now this pipeline has been started, and it is waiting for the data. And as it is not receiving any data, it will go to the idle mode. So now let's give it some data and see the data flowing end to end. So what I will do is I will go to our notebook section, and then we will start pushing the fraud watchlist data continuously. So let me start this, run this cell so that it starts sending the fraud watchlist data. So now it has started sending the fraud watchlist data. And also parallelly, let's start the other stream as well, where we were sending the transaction related data. So this is the fraud transaction. Let's send the normal transaction so that that will be having like lot much more data, and that is with the name normal. So let me run this. And it has also started sending the data in real time. And parallelly, let me go to another tab, another terminal here. So here we will also call the fraud transaction. Let's send one fraud transaction as well. So it has sent this transaction and it has exited. And our normal transaction, it is going continuously. And also our fraud watch list data, that is also going continuously now. It is running. So now let's go ahead and look at our pipeline. So here we can now see some real data coming in. So transactions also data is coming, fraud watch list also data is coming properly. And now the high value transaction alert. So one transaction we has sent as a fraud transaction with high value, that has been also detected here, and an email has been sent for the high value transaction. And similarly for fraud card alert also, it has detected like one fraudulent transaction, and for that also it has sent the email. And for these window functions, currently this is in idle state. I think it is currently waiting for that a 5 minute window, then it will start doing the aggregation. So we will let it run for some time. Parallelly, let's go ahead and check our email. So here we can see now multiple emails coming one by one of both the types. So this is how it is running fine end to end now. And this is how like end to end flow of streaming data looks like. So now both the streams, the data is coming continuously. Even if we go to our pipeline graph, it will also show the same, that this is also running, this is getting the data, this is from bronze to silver we are getting, then all these aggregations are happening, these frauds are being detected, and emails are being sent in real time. And these watch list also we are getting continuous data. This join also, it is happening like stream to stream join and then sending the email. And here the stream to static join is happening, and then the fraud email are being sent. So this is how an end-to-end streaming pipeline looks like. So I will let it run for this amazing pipeline. And now let's understand what is left for us to do now. So now revisiting our architecture again. So these pieces we have completed, all the data ingestion, all the data processing is done. And then consumption side, email alert part, we are done. So the pieces pending are the dashboard and the orchestration. So first we will prepare the dashboard and then we will prepare an end-to-end orchestration. So now let's go ahead and create our dashboard. So for creating the dashboard, we are not going to create it manually. I find it boring. And the Genie code, it can do a lot of things automatically when it comes to the dashboard part. So what we will do is first let's go out of this streaming pipeline. So let's go to the workspace mode. And now we will ask the Genie code to create a dashboard for us. And this time also, instead of writing the prompt here itself, we will first type it here. So we will say that create a new dashboard. And the dashboard we wanted to create from both our silver and gold tables. So here I want to give it some minimum instruction and then come up with a dashboard that we can customize later on. So I will say that step 1 itself, understand all the tables structure from FinGuard dot silver schema. It shall do this. And then what it shall do is it shall also do the same for gold layer. So it shall also understand the tables in the gold schema. And then it shall like prepare some, or we will say come up with some good APIs and prepare a nice dashboard for me. So this is the prompt we are going to give it so that it can understand all those tables automatically and then create a dashboard for us. So let's see what kind of dashboard does it come up with. So first it is doing a show tables in silver layer so that it can see the list of tables that are available. So looks like it threw an exception that the catalog is not found. So like always, I may have made some typo. Yes, so let me correct that. It is ZUARD. So now let me create a new thread and give this prompt again. This time we can see that it has found the tables and now it is trying to understand the structure of each and every table. Now we can see it has created a dashboard, a blank one, and it will open that and then create many things into the dashboard. So this is our blank dashboard that it has opened automatically. And now it is thinking what to do. Now it has come up with some KPIs that it is going to show us. And now it is setting up some data sets. So to create any dashboard, now it is starting a warehouse. Let me close this pop-up. Here it will create some data sets. So if we go to the data tab, we will be able to see whatever it is currently creating. So this one, it took quite some time. So I took a break and then I came back. So now I can see that it has completed the things. It has created so many data sets for us. So how it works is, this is a data set. First, maybe let me close the right side. So here, for example, from the customers table, it is applying a filter wherever risk score is greater than 70, and that it is counting as a high risk count customers. Similarly, this is another data set where it is doing a transaction count of today's data only. It is today's data filter from the transactions table. Likewise, it has prepared different SQL queries, and then it has also prepared this nice page with the visualizations. So from here directly we can understand what it has prepared. So these are the total alerts that has been generated today. So there are so many alerts which are running because the pipeline it was running for very long. After that I stopped it manually. And these are the number of transactions that has happened today, the data set that we just now saw. And this is the average transaction amount. So it is doing simply an average. These are high risk customer, the one that we saw. This is where it is showing alerts over time. So here, if we want to understand this, we can simply click it and we can see here which data set is being used here. So this one, it is alert trend over time. So if we go there and if we find the alert trend over time, so this is what it is doing here. So it is taking the alerts from both our tables of the last 24 hours. That is what it is doing, and it is doing a group by of the date, and it is taking our part of it. So for every hour it is checking like how many alerts we are getting. So for today, like it only ran I ran it only twice today, so that is why it is showing only two entries. Here it is showing a breakdown, like for high value transaction how many alerts are there. So this is the count. We have only two because this data we were sending manually. For fraud watch list, we have so many alerts that were generated automatically. Here it is showing top 10 customers by the alert count. So this one, it is preparing from the by joining the different table, the customer table and the other table probably. And this is our alert distribution, sorry, alert status distribution. So here it is taking some status column which is always approved. This one doesn't seem to be that useful, I would say. This is our transaction volume by minute. So this is what it is preparing from our aggregated table. So minute by minute, it is showing how many transactions has been performed. And recently I have stopped it. So the number of transactions has dropped. This is our transaction amount by merchant category. Then this is saying whether the transactions has been domestic or international. These are the top 10 merchants by the transaction count. This is the country wise transactions. This is some risk level distribution where currently there is no data coming in. Maybe there is some null column or something. And this one, it is the payment channel, from which payment channel is being done for each and every transaction. So this is a nice dashboard that it has prepared. And for any of this, if we want to customize it, we can customize it. For example, this one doesn't seem to be useful, so we can simply delete it. We can adjust anything that we want. And any of the chart, we can customize it as well, however we want to from this right side. For now, we will not focus on much customizations because our intention was to show a nice dashboard. And this is how the dashboard looks like. This page also, we can rename it to anything. We will rename it to fraud monitoring. And that's all. With this, we can say that our dashboard is ready, and we will publish this dashboard so that other users, they can use it. And now the dashboard has been published, so it is available. So if we click here, it will show the published version of this same dashboard. So this is how the published version of dashboard will look like to the end users. So now as we are done with the dashboard, let's see what is pending next. So now we can see that all these pieces we have completed. Only the orchestration piece is pending now. So let's go ahead and do this one. So for orchestration, so there are three pieces to our architecture. So one is batch processing pipeline, one is streaming pipeline, and one is this dashboard. So for streaming pipeline, we do not need any separate orchestration because once we change the pipeline to continuous, it is always running. So there is no separate orchestration required for that. And for dashboard piece, we get a schedule option. So this one, we get an option how frequently we want to refresh this dashboard. So if we are preparing it for near real time so that we can monitor the transactions at the minute level. So the minimum refresh time we get is every 1 minute. So if we do that and if we create it, so every 1 minute it will start refreshing this dashboard. So that is how we can orchestrate this dashboard. And now the only piece that is pending, this one I cancelled it because I don't want to actually do it now. And the only pending piece is the batch processing pipeline. So how do we orchestrate the ingestion and then the silver pipeline there? So for that, we will create a orchestration job. So we will go to jobs and pipelines. We will click on this jobs part. So other than jobs, the ingestion and ETL pipeline we already covered. This was the only pending piece. So here we will say customer ingestion uh, source to silver. And in this one, there are going to be two steps. So first we will run a ingestion pipeline that will ingest the data from source to bronze. And type will be pipeline only. And here by default, it is showing ETL pipeline only. But our pipeline, it is an ingestion pipeline. So here we will select our FinGuard customers ingestion pipeline that will ingest the data. And then we will save this task. After that, we will add a new task. This new task also, it will be a pipeline. This time it will be a ETL pipeline. So this one, it will be bronze to silver. And here we will select the pipeline. And here we will select the pipeline that we had created for customers table bronze to silver ingestion. So this is the pipeline and we will save it. So that's it. These are the only two tasks we need to do there. And then we can run it manually from here so that it will first ingest the data from source to bronze and then to silver. And after testing that, we can add a trigger here as well. So trigger type, it can be scheduled in this case because we want to run it every 1 day. That is how we want to do it. So this is the default one. If we want to select a specific time when we want to run it, so every day it will run at this time. So time also we can select. And then if we save, so every day it will do a batch ingestion for this test, for this table. So the streaming part, it will keep running continuously, and batch part, whatever latest data is available in our silver customers table, that will be used, and every day it will be refreshing and new data will be used. So that is how the end-to-end orchestration of this project will look like. So basically this process, it will run once a day, then streaming ingestion, it will run continuously, and dashboard refresh, that will happen every 1 minute. So then it will be running end to end continuously, and all the data that processing, it will happen in real time. So that covers the orchestration piece of our architecture. So now to summarize, we have completed each and every functionality in this architecture. We have done hands-on. We started by streaming some data from Kafka, loading it through bronze and silver layer. Then we brought in the batch data, the customer data from Postgres SQL through Lakeflow Connect and ingested into bronze and silver. And after that, we brought in the streaming data using autoloader as well from our volume. And after silver layer, we did all these types: stream to stream join, stream static join, fraud detection, everything in real time. And then we sent the email alerts and prepared a dashboard. And we did overall orchestration using Lakeflow job. And then we used Unity Catalog to prepare all our tables in Unity Catalog with proper governance. So these were all the details I wanted to share in this video. I hope my efforts that I put in to create this video were worth it. So if you think that those were worth it, please put it in the comment section and let it out. And if you have any doubt or if you come across any issue related to this project, then also please put a comment. And I will suggest that you do a proper hands-on on this project end to end so that you are more comfortable if you want to show it in an interview or something. And then only you will not forget anything once you do a practical. And you can also get the PDF that I have prepared that you can use as a revision for this project whenever you want to have a quick glance. So you can go over the PDF and use it so that you can show it properly in the resume and you can be ready for the interview whenever you want to showcase this project. So that's all for now. I hope you really liked it. So let's stay in touch and let's see what's coming in the next video. For now, that's all. Bye bye. Happy learning.